Hey guys, and welcome back to an amazing new video, which will be a very long video, but probably right now it will be the video you will be able to learn the most on my whole channel. I will say it will probably be 2 or 2.5 hours. I estimate you will already see the time. But let's actually first of all check what we will build here. It will be a stock market app, so we can essentially browse through stock companies here around the world. I think it's pretty much America. At least I didn't find any German ones or so, but just tons of stock companies here. And we have a search function here. We can, for example, search for Tesla. Then you can see we find Tesla. All of this is actually saved in a local database cache. So we get all these stock listings from the API once, because you've seen those are quite many. So it makes sense to cache these in a local database, so we don't need to make this request to the API every single time we launch the app. Then, if we search for this, obviously the search is also a local search here, so it's pretty quick. We find our desired company here. In this case, it's Tesla. And if we click on that, we will get more information about the specific company and the stock prices. Let's see. And you can see it's a nice looking detail page here. We see, okay, Tesla, the symbol of that for the stock market, which industry, which country, some kind of description. And what I really like is this market summary. So you just get an impression of how the stock price for Tesla actually developed throughout a single day. So this is just one day. You can see here this would be 5 o'clock, 7 o'clock, 9 o'clock, and so on. And this would be the equivalent stock price. So I know this is a very long video, but if you don't watch this till the end and you actually want to learn how to structure such an app, how to do local caching and all that stuff, then I really can't help you, because I actually thought about making something like that for a paid course, but then, okay, I thought about it. Let's put it on YouTube so everybody can learn from that. But it would be a really big favor if you would actually watch it and actually learn it, not just for the watch time, but also because I want that you really understand these concepts, because that's what really counts in the end and what it comes down to when you want to work in a company. And that is that you can build solid apps with following solid principles, with following a good architecture and all that stuff, which you will learn in this single video here. So definitely make sure to watch this till the end. Let's first of all cover what this video will actually teach you. So all the concepts that I will cover here in this course. On the one hand, that is of course getting JSON data from an API. That is probably nothing new for most of you who watch my videos. So this page will be partly coming from JSON data, so at least the details here, like the name, the description and stuff like that. But we will also have a different part that I haven't showed yet on my channel, and that is CSV parsing. Because in finance and in stock market APIs, it's very common that you actually get the data not as a JSON format, instead as a CSV. So it's a table format. And that, of course, works a little bit differently in Android than just getting it from a JSON file, which we can easily just parse with Moshi, JSON, or whatever. But for example, all these values here we make this graph from, they actually come from a CSV file that we get from the API. The same for all these listings here. If we remove this search field, then all these fields actually come from a CSV file as well. We parse that CSV file with the OpenCSV library, which you will learn here in this course. And then we will put it in a local cache to easily and quickly load that here into the app. So then what else will you learn? Of course, as I said, you will learn how to cache all this. So how you can get something from an API and put it in a local cache. And of course, use that local cache as a single source of truth. So we load everything from the cache. We never show directly from the API. Instead, we load it from the API, put it in the cache and display it from there. I will get more into this when we get to the caching part. Then, of course, you will learn, if we, for example, look up Google, which is called Alphabet. If we take a look here, then of course you will learn how to make this graph, which I think many will find quite exciting. I really like how this looks like. You can of course customize it, choose your own colors and all that stuff. That will be a little bit more complex. We will use a canvas for that and all that stuff. But we will get to this probably at the very end of the course. Then what else will you learn? Well, dependency injection with Dagger Hilt. So that will be covered. And just, yeah, the whole picture of building such an app. It will be a clean architecture app in the end, except for using use cases. I don't like to use use cases, to be honest, so I leave them away because very often they just introduce boilerplate code and just call a repository function. So I personally usually don't use cases. I like clean architecture, but without use cases. I rather have some kind of manager classes that have a single responsibility but don't just contain a single function. Then what else is actually important here to follow through this video? I know that's a lot of introduction here, but it's important for a long video. That is, on the bottom side here, you will be able to find checkpoints, I will call these probably. So you don't need to watch this in one go, of course. I will have some checkpoints where you can actually jump to, and you can start from there. If you find some parts boring, then you can just skip these and jump to next checkpoint. For each single checkpoint, I will actually have a separate branch on my GitHub repository, so you can simply pull that branch and start from that checkpoint. Or if you messed up somehow, then you can just either just check the code for that specific checkpoint, or you just get it from GitHub and continue from there. So down in this video's description, you will find a link to this GitHub repository. Right now, there is only a master branch and an initial branch. You will use the initial branch, so you click on that to actually get the initial source code containing the dependencies, just the initial setup that doesn't involve any coding, that's just copying and pasting stuff. You simply, you simply go to code, you copy this, and then you paste this in Android Studio. So when you go to Android Studio, you actually go to File, New, Project from Version Control, and here you paste that URL and click Clone. Or you simply download it as a zip file. Then let's get to the API that we will use, and that is AlphaVantage. So you can find that on alphavantage.co. I will also link that down below. And here you will need to get a free API key. It's very easy to get that. Sadly, you don't have too many calls here. So I think they have 5 calls per minute and some other limit per day. But yeah, this is for learning purposes. Of course, this is not intended to be released to Google Play. So here you need to just tell them what you are. You're a software developer or a student, organization, whatever. Enter your email, confirm that you're not a robot. And then they will simply send that via email. It's very easy. And here's the documentation for that, which we will get to later when we actually implement the actual API stuff. So I don't want to get into this now. Very quickly, the initial setup here. If we take a look in our build.gradle app file, we see that there is a little bit non-default stuff. Let's actually just jump to the dependencies to see what that is. OpenCSV is the library that we will use to parse the CSV files from the API. We have the compose dependencies, and a lot of these are actually not needed. The flow layout isn't. I just pasted these from another project. Paging isn't needed, but the rest is. So we have ViewModel stuff, activity compose. The icons aren't probably needed. I'll just leave these in before I mess up here. And swipe refresh layouts here, so we could use that to refresh the company listings. We have compose nav destinations, which is a great library for navigation in Jetpack Compose, which I also have a separate video here about on my channel, which is just a lot easier than the normal compose navigation. We have coil, which we don't need, to be honest. We have Dagger Hilt, obviously for dependency injection, Hilt navigation compose to inject view models, retrofit to get JSON data and to download the CSV files. We have room and routine support for rooms. Yeah, that's it. So you get this from my GitHub as I showed you. And I think other than that, we are ready to jump into it. And I actually want to start setting up our package structure. So when it comes to clean architecture, what we do is we divide our app into 3 main layers. Many of you will already know that from my other videos. And that is data on the one hand, then we have domain, and we have presentation. The data layer is, I think, pretty self-explanatory. So that's where we put our actual data related logic. So retrofit stuff, room stuff, CSV parsing, everything that's related to data, to files, to preferences, and also these concrete implementations of how we get data. And that belongs into the data module or the data package. Then we have the domain package, the domain layer, which contains our actual business rules. So our app somehow has some kind of rules, for example, how we would like to filter specific entries from, for example, the search logic here. All that is business logic that would belong in the domain layer. We also keep our entities and models there. So basically, for example, a CompanyInfo object that contains information about a single company and its stock prices. All that stuff belongs in domain, which is the innermost layer. So every other layer is allowed to access domain, not the other way around. So domain shouldn't be able to access any other layer. And finally, we have presentation, which is used to show something to the user, to present something. So that will contain the UI, our screens, our state, our view models, all that stuff. Usually for a project, I would choose to divide it by features and then every single feature by layers, because that just makes it scale a lot more, because you don't have, if we choose a single layer, a simple layer-based separation, let's just do this. I think it's better if I show you that. If we have like data here, then we have a domain package and we have a presentation package. If we divide it like that, then if we have a very big app, then our presentation package will contain all of our screens from our whole app, which can very quickly get very messy for a bigger project. So usually what I do for bigger apps is I have feature modules, feature packages here. For example, for displaying some stock information here, this app would just be a single feature because it's a very small one. But if you have bigger apps, then you have more features. And then inside of these features, I would divide them by layers. So by data, domain, and presentation. Because that's a small app, I leave it like that, just as a little disclaimer here, so you don't use this for bigger apps. Inside data, we will create more packages. On the one hand, a CSV package for CSV parsing related logic. We will have a local package for our local data source. The same for our remote data source, so remote. And do we have something else? Yeah, we do, for repository. So what that is, if you don't know that, I will get to it when we create it. And in remote, I will actually have another package for our DTO objects. That means data transfer object. So basically the objects that directly represent the JSON data that we get from the API. And then we will have domain level objects, which are our actual models that we map from these DTO objects. And when I talk about mapping, that's actually another package we need here for our mappers. Oops, that actually belongs in data. Let's move it into that. Yep, refactor. So that's it for our data package. Let's collapse that. In domain, yeah, we're just going to have a model package. Well, we have something else there. Actually a repository one as well, which I will explain when we get to that as well. And in presentation, we will just have a package for every single screen we have. On the one hand, that is our company listings. So the default screen, the launch one. And we have a company info screen when we click on a company listing and we get to the detail screen. Yeah, and I think we also want to have a util package in the root level. So util. I think that's pretty much our package structure to start with. I just like to set that up once when we start with this, so we don't always need to switch between setting up packages and coding. So what will we actually start with? I personally like to start with the data layer because that's usually the most complex one. Oh yeah, the biggest one as well, because here in this app we have a lot of data related logic, databases, CSV, APIs. So that's why I want to start with that, so we have that out of the way. And the first thing I want to do is I want to actually build our company listing screen. So the first one with a list of companies. Let's take a look into our API documentation here. On the left side, you will see listing and delisting status. That is what I am interested in. Of course, you have tons of more options here, which we don't need. And here's an example. So under examples, you can click this link to download a demo. Then you will get a CSV file and you will see how that looks like. I already did this here. So this is in the end a CSV file, which contains all that data for every single company that we get from the API. And we will parse this table and put it in our local cache. So you will see that we have single columns here. So symbol, name, exchange. It's in the end pretty similar to JSON, just a different format. What we do is inside remote, we start to create our API interface with a retrofit, because we will use retrofit to download that CSV file and then actually take the byte stream, so the stream from the API, and actually parse it with OpenCSV. So let's call it stock API and make it an interface. That's how it works with retrofit. Let's click don't ask again. And there we go. So to start with, we will have a suspend function here to get the listings. And will this take any parameters that we need? Of course, that is our API key that we need to attach as a query parameter here. So we will have a query parameter here from the retrofit library. And we call this API key, just like that. Call the parameter like that as well. And we of course need to get this into our app. I won't do any fancy hiding here of the API key. Since it's just a free one, I will just put it in a companion object here. So const val API key. And let me quickly copy this over here. This is my API key. I also won't blur this. Feel free to use this. It just has 5 uses per minute, if that's enough for you, or you just get your own one. And we want to have a base URL. And that is alphavantage.co. Yes. So just the first part of the URL, obviously. Let's also have HTTPS here. There we go. Get listings is not finished yet. So we provide our API key. We need to provide the full URL here. So what comes after the base URL. And that will in the end be get request. Because we get something, of course. And that will be query question mark. And we need to specify a function. And that is listing status. So that's just a query parameter that will always be the same here for this function. That's why we don't need to provide it as an optional parameter. And that will essentially get the listing data in form of a response body. So with retrofit, we can use a response body to simply get access to a file stream and to download that file, or kind of get access to the byte stream and make use of that to read it. And that's already everything for the retrofit side. That's all we need to set up here to download something, to download the CSV file. Next is to set up the local database in which we want to insert the downloaded entries that we get from the CSV file. So in our local package, we right click and create a new Kotlin class. And I will call this company listing entity. Because in the end, an entity is something we put into a database, and we put this in a local package because it's part of our database. That will be a data class. And we annotate this with entity. So we tell Room, our database management library, that this is essentially a table in our database. And now we define the data that we actually want to save in that database table. Well, what is it? If we take a look at our CSV file, what kind of data are we interested in? Well, we want to show the symbol of the company, we want to show the name, the exchange, and I think that's it. Yeah, the rest is pretty irrelevant here. So we use this here to, on the one hand, have the name, which is a string. We have the symbol, and we, of course, have the exchange. So which stock exchange that is. And since that is a local database, we also need a primary key, which we use to distinguish between different entities. So every entity is unique. So val ID is an integer, let's set it to null, and we annotate it with primary key. So then room will automatically generate these unique identifiers for us. And now when it comes to clean architecture, what we do is we on the one hand have these entities here in our data layer, or DTO objects, which would be the equivalent to an entity, just that it comes from an API. And we take these objects and we map them to domain level models. Because in the end, what we want to avoid is that we pollute our presentation layer with data related logic. So we really want to have that clear separation of layers here, that our presentation layer does not access our data layer, and yeah, especially not our domain layer or our data layer. So that's why we have a middle layer, which is the domain layer, with a model package in which we have another company listing model, which we just call company listing without entity or so. And that will contain the relevant data here of our company listing entity, which is this. It doesn't need an ID. And by doing this, we make sure that this has nothing to do with any type of third-party library, like with Room, with Retrofit. No, it's just a plain Kotlin class. And we will only use these types of domain level models in our project to show them in the UI, like the company listings. That has the advantage that if we at some point decide to change our API or to change our database, like for example to Realm, which is another popular database framework for Android, or another API library, then we don't need to change these domain level models, because they are independent of what kind of third-party libraries we use in our data layer. So then we only need to change these entities or the DTO objects, because only these annotations here in the end change if we change the library. And that's what actually, we use these annotations here in the data layer because they come from a data level library. And if we would use that in the domain layer, then that would mean we would use data logic in the domain layer. That's something we want to avoid. I hope that got clear, because this can be quite confusing for beginners, why we have two classes which contain almost the same data, but to stick to clean architectural guidelines, we have to do it like this. Well, how do we now take such an entity and transform it to our company listing domain model? For that, we use so-called mappers. So we go to our data mapper package and we create a company mapper. That's just a plain Kotlin file. And here we create extension functions that define how we take a company listing entity and we transform it to a company listing model. So company listing entity to company listing. And here we just return a new company listing object with the name being equal to the name of the entity. The symbol is equal to symbol and exchange to exchange, because the domain layer is the innermost layer in clean architecture. That means every other layer is allowed to access that. That's why we define these mappers here in our data layer, because the data layer is allowed to access the domain layer. So yeah, we're fine to access these classes here in the data layer. Then let's take another, basically the same function, just the other way around. So we have a company listing, a domain level object, and we convert it to an entity. Let's change that up here. And the ID will be automatically generated. So now that we have our entities and that we're able to map these, the next step is to define our DAO, our data access object. That's another interface, basically what the stock API is, just for a local database, where we define how we want to interact with our local database, which queries we have, how we want to insert, delete data. That's what we do in the DAO. Belongs in the local package, since it's related to local database, and that will be the stock DAO. Interface, annotated with DAO, and here we define the functions, how we want to interact with the database. Those are in the end, I think, 3 functions. On the one hand, to insert our company listings. So when we get them from the CSV file, we want to insert them all into our database. Then we want to have a function to clear company listings. So in case there is an update, we want to clear our whole database and insert the new ones. And we have a query for simply searching our database. Starting with a suspend function, insert company listings. Here we will pass the company listing entities, which is a simple list of company listing entity. And to tell room, hey, we want to insert something, we annotate this with insert, and we pass an on-conflict strategy of replace. So if we insert a company listing entity with an ID that already exists, we will simply replace it. Then we will have a function to clear everything in our database. So suspend function, clear company listings, and that won't return anything. But we annotate this with query because that is in the end a query where we want to delete everything from company listing entity. That's how we clear our database. And we have a final function that's a bit more complex to search something in our database. So suspend function, search company listing. And here we will pass a query, so what we want to search for. And that will now return something, and that is a list of company listings. So just the search results. Let's now define the query for that, which is a bit more complex. So let's use triple quotes here. And for that, we want to select everything from our company listing table. And now we define a where clause. So where, which is the condition, lower colon name, actually without colon, because it's not a parameter, is like percentage. And I will explain what that means once we wrote this here. Or, actually not or, we will use these here instead, and that is not an or, I will explain it. Lower, actually, query here, and these or symbols again, which are not an or, percent again, and now we use an actual or. The query is equal to the symbol. Actually, we say upper query is equal to symbol. Okay, so what the heck does that mean? In SQLite at least, these mean that we concatenate some strings. So it's what in Kotlin, it would be simply a plus. And what we do here is we construct a string. So we convert the name to lowercase, we convert the query, what we search for, to lowercase, and then we put these percentage symbols in between. So for example, if we search for Tesla or just Tes, then that would be our query. So even, let's say we would search for TES and a capital E. And first of all, we would take the name of the company and we would compare it here to this string. So in the end, what SQL does here is it puts percentage symbols here and converts this, the search query here, to lowercase. So it would be Tes. And now with this like function, the like operator, we check basically if the name to lowercase contains TES. So that's what these percentages here mean. So it's a placeholder. It could be anything, any sequence of characters. And then if that fits, it's a match. Or if we convert the query to uppercase, and that's equal, like exactly equal to the symbol of the company, then it's also a match. So if we either search for the symbol of the stock company, or if it contains the query in the name, then we will find it. Hope that makes sense. The next step is to implement the database itself. So now we have to DAO to Excel so Room knows how or what we want to access in our database. The database itself, the class for that is very easy. In local, we create a stock database. Will be an abstract class, so Room can generate some stuff. Will be a Room database. and we annotate this with database. First of all, we define the entities in form of a simple list. Whoops, now I have it. So the tables we have in our database, we only have a single one since we only cache the listings, is company listing entity :class. And the version is just 1. So every time you update your database, you need to increase this version. In here, we will have an abstract val for our DAO, which is a stock DAO. And that's already it for this class. So Room will just use this as information about the database and then generate all the boilerplate code behind that to create the DAO and all that stuff. So that's already it for the database. And with that, you already reached checkpoint number 1. Congratulations. So here you will find a branch in the GitHub repository down below from which you can continue or jump back to it, jump forward to it. The next checkpoint will cover creating the repository, which we will work on now. So in Clean Architecture, when we create a repository, then what we usually do is we have an interface that represents the functions our repository needs to implement, and we put that in the repository package of our domain layer. And then the actual implementation of that belongs in the repository package of the data layer. The reason why we do this is, again, the same reason why we have like a model here for company listings and an entity here. It's just that later, when we access our repository, which just takes care of the caching here in our app, when we take this and put it in our view models, which access this repository, then the view model should only be able to access classes from the domain layer. So that's why we actually use an interface here in the domain layer. Let's create that. Call it StockRepository. And since that's in the domain layer, the presentation layer is allowed to access that because the domain layer is the innermost layer and every other layer is allowed to access it. However, if the repository would be in the data layer, then this shouldn't be the case, that the presentation layer directly accesses something from the data layer, because that's concrete implementation, and if that changes, then you also need to change your presentation layer. That's what we want to avoid. So as I said, here we will now define the functions that the repository needs to implement. And right now that's just a single function to get the listings, like the company listings, from the API. So suspend function, get company listings. And before we actually are able to further implement, or rather specify, the function signature here, we need to create a utility class. Because what we want to be able to do is we want to take this repository and we want to easily handle the success and error case. So of course, when we deal with remote data and an API, it can be that things go wrong, and we want to catch that. We want to be able to find that and get that error in our view model to then show it in the UI. And for that, which you will already know if you watch my videos very frequently, I like to create a resource class. So in util, we create a resource class, and that is a sealed class. This will look complex, but it actually isn't. So in the end, that will be a generic class. Let's give it a type parameter t. And it will, on the one hand, have a variable for data, which is of that type and null by default. And it will have a message, which is a nullable string and also null by default. So this class will be used to distinguish between success and error cases. If we have a success case, we want to attach some data here. And if we have an error case, we want to attach a message, an error message. So let's see how this looks like. We have a data class for success. Actually, not a data class, just success, and we put a data parameter into it, which is also here of this type t, and that will inherit from a resource of type t, and we pass our data here. Let me just write this here down, and then I will explain how we will use this, but it makes more sense if we just use this, and then it makes total sense. It's really not a difficult class. We have an error case here, also with t. No Siri, not today. And here we have a message, which is actually not nullable here, because if we have an error, we always have an error message. And we have data, which is optional, because we could still get an error from the API, but in that case, we could still attach some data, which is the data we could load from the local cache. So resource T, and we pass data and message here. So that's in the end just a way to distinguish between success. If we have a success case, we just wrap this resource around some kind of result object. For example, the list of companies that we get from the API. We can then retrieve them using this data parameter. And if we get an error, we get an error message. I want to also add another class here, which is a loading class, to easily also get loading states from the repository. And here we have a variable, a val is loading, which is a Boolean, and by default it's true. So we can, whenever we receive such a loading resource, which will in the end send into a flow, then we can use this parameter to just be sure, okay, should we now show a progress bar or not? Resource T and pass data, which we of course don't have here. So we don't have data, so we can just attach null. Cool. So now that we have this class, let's go back to our StockRepository interface. And let's think about what this will return. Well, you could think that this just returns a list of company listing. So our domain level object. What you shouldn't do is you shouldn't use the entity here, because you are in the domain layer here in the interface, and the domain layer should not access the data layer. So that's why we avoid this. So of course, if we want to get company listings, then it makes sense to get a list of company listings. Well, yes, but what I just did is I used a resource class to distinguish between success and error case when we retrieve this list of company listings from the API. So let's actually put a resource class around this. So now, if there was an error, this resource class that we return will be equal to this class. And we can get the error message from that and potentially data, but not in every case. And if it's successful, we instead return a success resource that contains the data, which is, in this case, the list of company listings. But that's still not it. Because we have a local cache here, what we will do is we will actually return a flow from Kotlin X coroutines. And now that's the final return type. Looks super complex, but in the end it makes sense. A flow is used, it's basically a coroutine that emits multiple values over a period of time. And that's exactly what we want to do here. So we have our API and we have our database. Let's start with the database because that makes more sense. First of all, before we even load from the database, we want to tell the view model, hey, view model, you should now start showing the progress indicator. You should now map the state to have the isLoading Boolean equal to true. So we send a loading resource into this flow. Then what we will do is we will actually load the data from our local cache, because that's very quick and we can immediately show that. Then if we retrieve the data from the local cache, we actually emit a success resource with that list of company listings from the cache. And then at the same time, we actually also request new data from the API if we want that, to update our cache if there is an update, or to just populate our cache for the very first time. So there are multiple steps involved and multiple results we get over a period of time. Like, first of all, no result, just loading. Then we get the list of companies from the cache. And then after that, usually we get the list of companies from the API. And that's why we use a flow. So just to emit these different results over a period of time. Will make more sense when we implement this. This will take some parameters here, actually two. And on the one hand, that will be a Boolean fetch from remote So if we set this boolean to true, then we want to basically get the remote data again. That's why we have the swipe refresh layout. So when we swipe down to refresh the list, then we will force this function to get the data from the API again. If this is false, then we will just get the data from the cache and we save ourselves an API request. And it will take the query. So what we actually want to search for in these company listings. Later, we will extend this repository interface with more functions. For now, we're fine. Let's now write the implementation of that, so the actual caching functionality. We will do this in a repository of our data package, because that's now data-related logic. We route the actual implementation and we tell it, hey, we want to use a room for caching. It's a very specific thing, and that's why it belongs in the data layer, of course, because room is data-related. So StockRepository implementation. And since we use Dagger Hill to inject that later, I will explain a bit more about that when we get to this point. But what we want to do is we want to make sure to annotate this with singleton. Just make sure we only want to have a single stock repository in our whole app. Just one instance of that. And we will have an inject constructor here. So we will make sure that Dagger Hill will actually provide all the constructor parameters here for us, so we don't need to create this on our own. So what kind of objects do we need here in this stock repository implementation? We, of course, on the one hand need to access our API, our database, and, well, the rest will be implemented in the next checkpoint, I think, which will be the CSV parsing. We will also need some classes for that. Let's start with the API, which is our stock API, and our DB, which is our stock database. Make sure that this actually implements our stock repository interface. And then in here, we can implement the get company listings function. So now we need to return this complex thing here, which is, yeah, not too complex if we actually implement it. It will make sense. So what we do is we return a flow, this flow builder. And in here, we now have access to emit. Whenever we call emit, this flow will kind of throw out the value, whichever we pass to this emit function, and we can then catch these values later on in our view model. So first of all, what we want to emit is, we want to emit a loading resource. So you can see, since we have a flow of this type, we now need to emit exactly that type. So we say emit loading, resource.loading, and well, are we currently loading? Do we now want to load or not? If we're at this point, of course we do want to load, because we're just about to start our database query. Then after we emitted that value, that result, we now want to actually get all the company listings from our database. And for that, I want to use our DB and just get access to the DAO. So db.dao, just to that we don't need to write this all the day. So in here, we want to have a val local listings. We use our DAO to search company listing, and we provide the query that we pass as a parameter here. All these are now suspending calls, so these will suspend the flow. And after this, we have successfully loaded the local listings. If the database is empty, then this will simply be an empty list. So at this point, we are ready to actually emit a success resource, because reading from the database is pretty much always successful. So we can just say emit resource success. And well, what is the data that we want to now attach to this emission? That is a list of company listings, actually, yeah. And if we take a look at this local listings, then you can see that's a list of company listing entities. So that won't work, so we can't just pass our local listings here. That's what we have our mappers for. So the job of the repository is also to take the specific entities and DTO objects and map them to the domain level objects that we can then easily use in our view model and presentation layer. So what we can do is we can simply say .map, and for each object we simply want to map it to a company listing, and suddenly the error is gone. So that's how we do this. And at this point, our view model will receive this local list and can already show that in the UI. We haven't started any request yet to the API because that usually takes a while, and we are ready to show this local list first, of course. So what comes next? Next, we actually want to check if we actually do want to make an API call, because if we don't actually swipe to refresh and we already have valid data in the cache, then we don't need to make an API call to get that huge list of data again. So we can simply have a condition here to check if the DB is empty, and that will be equal to local listings is empty and our query is blank. So if this is true, we know that our database is empty. Why do we check if the query is blank? Well, if the query is blank, we know that this local listings list will contain all the companies. If our query is, for example, XYZ, and there is no company that contains XYZ in the name, then local listings will be an empty list, even though there might be some entries in our database. Just for that search query, we don't have any entries in this list. So that's why we really want to check if the query is blank and our local listings is empty. So that's really the initial state, and we don't have anything in that list. Then we know it's empty, and then we can check if we should just load from cache. And that will be if the DB is not empty, and we also want to not fetch from remote. So if fetch from remote is false, we obviously don't want to fetch remote data. But we also want to check is that the DB is actually populated already. If it is already populated and we don't want to refetch, then we just want to load from the cache. So the very first time we will always load from the API because we don't have anything in the cache. But from then onwards, we will only load if we actually swipe to refresh. So if we should just load from the cache, we just say we emit a resource.loading with false. So now we don't need to load anymore because we're done with this, with this flow in the end, because we don't make any type of request and we want to simply return at flow. And by the way, a little bit of a tip here for readable and clean code. I could have also just done this and removed this Boolean, but I wouldn't do this because if you get back to this code here in a week, in 2 weeks, and you look at this condition, then you first of all need to think about why do you have this condition. It's not immediately clear what this checks for. So if you have something like that, always make that a separate Boolean, and this is a lot more readable. You can directly read this as if it was a sentence. So if we just want to load from the cache, then we do this. So it's pretty readable. You don't need any extra comment for that, which is something you usually want to avoid to describe what happens with a comment. That just means that your code is not written well enough to be self-explanatory. Just as a little quick tip here for clean and readable code, let's go on here with the rest, which will contain the API call. So that will be a list of remote listings. So remote listing is equal to try and catch, because when making an API call, things can go wrong. We want to catch IO exceptions, and we want to catch HTTP exceptions. So IO exceptions happens, for example, when something with the parsing goes wrong. HTTP exceptions happen when there is an invalid response. In both these cases, we just want to print the stack trace and want to make sure that we emit a resource.error here with, I'll just hardcode a message here, couldn't load data. Depending on the exception, you could, of course, have much more fine-grained and specific error messages here, but I'll leave that up to you. However, in that try block, we want to get the response using our API. So get listings, and the API key, we actually don't need to specify that. So in stock API, let's just set this to the default here, because then we don't need to provide any parameter here for that. And now, that response is a response body that comes from OKHTTP, which is what Retrofit uses underneath. And here we get a byte stream. And this byte stream can now be used to read the CSV file. That is what we will actually do next. So what we could now do is, and what is the naive approach here, which many beginners will actually choose and prefer, is that we now actually start to write our CSV parsing related logic just here. So we could have like a CSV reader. That's how we do this. CSV reader that takes a reader, which is, for example, an input stream reader, and that takes an input stream, which would be response byte stream. So that's just very quick how we could do this, but I don't recommend doing this because it violates the single responsibility principle from the solid principles. That means that every single function, every single class should only have a single responsibility. This function should have the responsibility to just cache data. It should not really have the responsibility and the task to parse CSV related data, because that's not what you expect when you read that function name. So that's why we will actually take all that CSV related logic and put it into a separate class. However, you already reached the checkpoint number 2, which you will also find as a branch on GitHub. So the next one will then deal with parsing CSV data and finishing off this repository function. So let's now actually create a separate class to handle this parsing for company listings. In our CSV package, which we have for that, I first of all want to write an abstraction for that. And that is actually another clean code solid principle that you should always depend on abstractions and not on concretions. What that means is, well, an abstraction would be something like an interface. It would be something like an abstract class, as the name already says. And a concretion would be the concrete implementation of an interface or of an abstract class. Like this implementation here for the stock repository would be the concretion, and this would be the abstraction. We want to depend on abstractions. So we want to depend on this stock repository interface, for example. We don't want to depend on this. What does it mean when we when we talk about depending in terms of code? We talk about dependencies. So the abstractions should be the dependencies. So basically what we pass to other objects. So for example, our view model later on will get access to this interface instead of to the implementation. So it will get a dependency to the stock repository interface, and it will not get a dependency to the implementation. The advantage is that once we change the implementation, we don't need to change all the classes that use it. We only need to change the stuff inside of this single class. That's why you should depend on abstractions, not on concretions. And that's also why we will create an interface for our CSV parser. So in CSV, new Kotlin class of file called CSV parser, and make that an interface. And here, we're just going to have a single suspend function to parse something, because every CSV parser should in the end be able to parse something. And depending on what we want to parse, we need a different CSV parser because the logic will differ. So we can have a generic parameter t here, which we need to put here. We need to provide a stream, which is an input stream, and that will return a list of that type t. So in the end, the parsed list from that CSV file. Let's now go to CSV and create our parser for that. So that will in the end be our company listings parser, normal class, and that will now implement the CSV parser interface. And well, what's the type here? Oh, actually, we don't have a generic for the class. Let's implement the function instead, Control I. You know what? Let's actually do this a little bit differently. Let's go here and not put the generic parameter to the function. Instead, let's put it to the class. And then we can say, okay, each company listings parser is a CSV parser of company listing. And then we can also get rid of that. That way it's a little bit better in my opinion. This will return a list of company listings here now. Okay, as we did with the repository as well, we want to make sure this is a singleton and we have an inject constructor. just for dagger hilt, that it knows how to construct this object. The constructor will stay empty. Don't be confused why that happens. We just need an inject annotation here in front of the constructor, so dagger hilt knows how to create such an object and provide it for other dependencies. So how will this work? We now get access to this input stream, and we need to take this input stream using our OpenCV library, OpenCSV library, and parse this to a list of company listings. So in the end, we just get access to a table, a CSV file, and we need to convert it to a list. As I already quickly showed you in the repository, we have to create a CSV reader for that, which is a CSV reader, which needs access to an input stream reader, and that needs access to our stream. And then we can actually return CSV reader .read all, and you can see that returns a list of array of string. So what that actually means is, if we take a look at our table, we now get a list of arrays of strings, and that's exactly our table here if you think about it. So each single row would be the array, so an array of string, like this would be the first field, second field, third field, and so on. And we now have a list of these arrays, so the whole table in the end. And yeah, we can then simply loop over that list and simply get access to the single fields. One thing we want to do here is, before we directly return this, is we want to say return with context, because we want to make sure that this gets executed in the IO dispatcher. And then, yeah, we will still get a warning here, which tells us, not here, but it will tell you, hey, this is a blocking method call. Don't use this on the main thread, because it can't check that we actually do this on the IO thread. Doesn't matter, you can ignore this. Oops. Then the next thing we want to do here is we want to drop the first field. Why did we want to drop this? Because the first kind of row contains the just what the column is about, and we don't want to put that. We don't want to make a company out of that. It doesn't contain any company data. That's why we simply drop the very first item. And then we want to say map not null. We now get access to a single line, and with this line we can now parse the single fields of that line. So the symbol will be the first field, so line get or null at the index of 0. Then we have the name, which is the second field of a row, line get or null at the index of 1. And we have the exchange at the index of 2. And we're not interested in any other fields. So now what we can do is we can construct a company listing object, because that's what we want to map this to. And the name is equal to our name. And actually, if this is null, we want to return null here in this map not null function, which will then simply ignore this entry, because we only map the non-null objects. The symbol will be symbol, and else return null. And the exchange will be the exchange. Just like this. You can see we don't have any more errors. One thing we shouldn't forget is, after all of this, we're going to say also, and take our CSV reader and simply close it. And that's how we simply parse CSV data. It's pretty easy, I think. And with this class, we have a single responsibility here just to parse company listings. We will then have a different parser for the intraday infos, which we'll later have. So that's just the information for a single day of a stock company. Because the parsing logic for that differs, of course, a little bit, and these indices here, we can't make a unified class for that handles it all. So we can't just have a single CSV parser. Instead, we need an implementation for every single type of table, kind of. So having that, you actually reach checkpoint number 3, and that will be a separate branch. And the next checkpoint, or the next part of this course, will deal with implementing the view model, implementing our state, implementing some events that we sent to the view model, and yeah, actually just calling the function from the repository. Oh no, let's actually wait, we're not done yet. When I talk about repository, I actually wanted to also do something with this parser. So this checkpoint is not fully done yet. Let's provide this here as a company listings parser, but that's not a company listings parser, because if we would do that, that would mean we would depend on a concretion, but we want to depend on an abstraction. So we instead depend on the CSV parser of type company listing. That way we depend on the interface and not on the concrete implementation of it. So when the company listings parser here changes, if we use a different CSV library or so, then our repository doesn't change because it just uses the interface. So down here in remote listings, what we want to do is, right now remote listings, it's just unit. So we don't have any type of list, but we want to return response, actually our company listings parser that parse, which will return the list of listings, and we pass response.byteStream here. And in the catch cases, we simply want to return null, because then we don't have any remote data. And if we now take a look here at the type, it's a list of company listings, which we got from the CSV file. So down here, after we finished the API call, what is now missing, of course, is that we take this and insert it in our local cache, so that the next time we launch our app, we will actually load the updated data. So if remote listings is actually not equal to null, then we first of all want to emit a success resource with these listings attached to the data. We want to then attach, what do we want to attach? A resource that loading with false, so that we stop loading, stop showing the progress indicator. Then we want to take our DAO to clear the company listings. Now we want to clear our whole cache, and then we want to insert the new listings. So insert company listings, and that will be our listings here. And we need to map these two entities. So we say map it.to company listing entity. And one minor issue here with this code is that we don't stick to the single source of truth principle yet. What that means is that we only get data from the database. So we shouldn't really directly pass data from the API to the UI. Instead, we should take it from the API, put it in the database, and then load it from the database again. So we really only have a single source where the data comes from. But right now we emit the data here as a success resource directly from the API, which we should avoid. Let's just make sure that we clear the cache before and we insert the entries then. And then instead of directly showing the listings here, we can say, okay, we instead attach a DAO, a .search company listing, and we can just pass an empty query here and make sure to map these to company listings. Let's do it like this. So yeah, that is a little bit less performant here, of course. I know when we directly have these listings here to attach, but I would value sticking to this pattern, to this practice of the single source of truth here. I would value that higher than this not noticeable performance benefit here. So I would always stick to the single source of truth because it makes things a lot easier if you know data is always just coming from your cache to your UI and never directly from other sources. But that's not really it for this checkpoint. So in the next one, we will then deal with the view model stuff. So as I said earlier, the view model belongs to the presentation layer. Let's put it there into our company listings package, create it here, Kotlin class of file, which will be the company listings view model. And for those of you who are not familiar with the job of a view model, it's basically just, it has the responsibility to access, or to rather, to call our data layer functions not directly from the data layer, but using this abstraction here, using this interface of the repository, and then taking this data it actually gets from the repository and mapping it to state that we actually can show in Compose in our UI to update our UI, and just to make sure that it keeps the state. So the state is also kept on configuration changes, like on screen rotations. When it comes to using view models with Dagger Hilt, we need to annotate this with Hilt ViewModel, because injecting stuff into view models is quite difficult. With Hilt, luckily it isn't, but there is a lot of stuff happening behind the scenes. That's why we need to annotate this with an extra annotation and have an inject constructor actually. And in here, we want to get access. No, Siri, not again. Private val repository, which is a stock repository here. So again, we depend on the on the abstraction and not on the concretion. And yeah, that will be a view model. Just like this. Before I actually go on here, I want to implement our state class. So a class that represents everything that belongs to our UI state on that particular screen. So in Company Listings, we create a new Kotlin class of file called CompanyListingsState, make it a data class. And now that contains everything, as I said, that is relevant for the UI state. So on the one hand, of course, it contains the companies, which is a list of company, not company info, it's a list of company listing, empty list by default. And then it will contain a loading boolean. So whether we want to show the progress bar or not, we have is refreshing, which is a boolean. So that is, if that's true, then we know that the swipe refresh layout is currently refreshing. And we have a state for the search query. So the text we currently entered there, and that's an empty string by default. And one other thing that I like to do for my screens is to have a sealed class for the different UI events we can perform on a single screen. So if we take a look here on our UI, then we currently take a look here at this left screen. So that's our company listing screen we're currently working at. Now, I like to create a sealed class with different types of events, which basically represent user actions. So everything the user could do that could lead to something happening, that would be an event. So for example, clicking on an item, then we want to send that event to the view model, and in the view model we handle it. So when we click on an item, then, well, in this case we don't send anything to the view model because we just want to navigate. But another type of event would be, for example, to refresh. So we swipe down and we refresh the list, or we type something into the search field. I think that gets clear. Let's create the sealed class here in Company Listings called Company Listings Event. Make it a sealed class. And okay, what do we have? On the one hand, as I said, we have an object refresh. Doesn't take any parameters because, yeah, we know what happens if we refresh. Just want to reload the data. And we have a data class on search query change, in which we will get access to the new query. So then we actually want to perform the search and map the new search results to the to state to show it in our UI. And that's already it for this screen. As I said, clicking on an item will not be an event since we can directly navigate to the new screen. Now back to the view model. Let's have a state here, val state by mutable state of, and import this. And this will be of type company listing state. And create a new instance here with the default values. And now what we do in this view model, or usually in each of our view models, is we have a function onEvent in which we receive such an event. And then we can very easily, check in a when expression what type of event that is. So if that is refresh, for example, we want to do this. And if it is on search query change, we do this. So that way we can very easily distinguish between different events, and we don't need a separate function for every single thing that can happen. Let's start with refresh. What happens if we actually swipe to refresh? Then we actually want to refetch our data from the API, of course. And for that, I like to create a function. So down here, let's call that function getCompanyListings. That will take the same parameters as the function from the repository takes. On the one hand, of course, the query, which is a string, and we set this to our state search query lowercase by default. And fetch from remote will be the Boolean, which is false by default. And in here, what we will do is we will launch a coroutine in ViewModel scope. And in there, we will make use of the function we get from the repository that gives us the flow. So here we will now retrieve the entries from our cache in the end. So repository get company listings, which returns that flow, and we pass our two parameters here. And let's do it like this. We want to collect the results. This will give us resources here. So let's call it result. Now we can very easily check when that result is resource success. Import resource. I can see how cool that resource class is, that we can very easily distinguish between success, error, and loading events. Let's start with the most easy one here. That's loading. So if we receive a loading event, we just want to map our state, of course. So state is equal to state copy, and is loading is equal to result is loading. I'm just noticing that the state should be a var, of course, so we can change it. Import this. There we go. Here for this particular screen, I won't do any error handling. I'll leave that up to you. I will do a little bit of error handling for the other screen, for the detail one. However, the success case is the one that we're interested in the most. Here we want to check if the result data is actually not equal to null. Then we get the actual listings. And if it's not null, we map our state to state.copy. If you don't know what this copy means here, is it basically creates a copy of the current state, and we can change the values here to other values. So it will be a copy, and we can, for example, just change the company list here. And that way we still keep an immutable state without having var fields, which is usually what you should do. Because that's a lot more helpful when it comes to multi-threading, that you don't get any race conditions. So in here, what we now want to change as companies is listings. Just like that. And then we can scroll up to refresh. And here we just want to call get company listings. And if we refresh, we definitely do want to fetch from remote. So we force that and we set it to true. That's it for refreshing. When the search query changes, we actually want to search and we want to get company listings with a new search query. And because we automatically search when we tap something, the solution for this that I will choose is we will have a private variable for the search job here. So we will keep track of the coroutine job, which is nullable by default. And whenever we type something new, we add a little bit of delay, like 500 milliseconds, until we actually start the search, because otherwise we would be searching all the time when we type something, making way too many queries for every single character that we type. That's what we want to avoid. And here, instead of this on search query change, we will first of all say, okay, state is equal to state copy, and the search query is equal to event.query. And then what we say is search job.cancel. So if we already have a search job running, we cancel it. Because now we want to relaunch it. search job is equal to viewmodel scope.launch. And we delay this coroutine scope for 500 milliseconds. If these 500 milliseconds pass, we say we want to get company listings, which by the way can be a private function. So in the end, what happens here is this is triggered for every single character we type. So let's say we search for TES for Tesla. We type TES, and that typing happens rather quickly. Then after typing the S, we actually stop. So that will be the first time the search job does not get cancelled. Because if we launch this and we delay for 500 milliseconds before we start the search and we type another character, this will be triggered again and we will cancel the current job. So it will actually never reach this place until we actually don't type something for at least 500 milliseconds. Then we will actually perform the search. So that's it for the view model. The next steps will be to, on the one hand, create our company listing item, which will just be such a single item here, like this one. And then just use that to create our screen, which consists of this search field and a list of all these items. And then after that, we need to set up degradHield. So we actually make sure that we are able to inject dependencies. And then we should be able to try this out, of course, without the detailed screen, but already to see the list, to test the cache, to test the search. So that will be quite fun. So let's actually start to implement our company item, our UI item. So just such a list item in Compose. So in Company Listings package, we create a new Kotlin file called company item and select file here. Make that a composable called company item. And well, what does it need? It of course needs access to our company listing. So let's just call it company here. It is of type company listing, just the data that it should represent, and an optional modifier from Compose is equal to the default one. Okay. So the very outer container will be a row where we will apply our modifier that we passed. Oops, not that one. Is equal to modifier, this one. And we want to make sure that we center this vertically, so all the items in this row. Then in here, we will make use of a column. This column will have another modifier, which has a weight of 1F. So what we'll do is we will basically make sure that this column here actually fills as much space as it can inside of the outer row, so that the titles actually have a lot of space, and then that these, if they end here and don't have any more space, we simply end these with an ellipsis. So inside of that column, one last time, we have a row, and inside of that row, we give it a modifier of modifier fillmax width, and here, well, that will now be this top row, which contains this text and this text. So text, the text will be like, that will be the name. So company.name, and then we want to give it a font weight of bold. We want to make sure that the font size is 16 SP. I won't use any text styles here just for simplicity, because it's a rather small app. Then we want to make sure that the color is material theme colors on background. That's what the text color should be. We have an overflow of ellipses. That's exactly what I mentioned here, that these texts get cut off here and don't abruptly end. And we set max lines to 1, so we make sure that the text does not go over one line if it gets too long. And one last thing is a modifier of weight with 1F again. Then we want to add a little bit of spacer here with a width of 4 dp. import dp. So that will be this minor space here. And then we want to have another text where we want to set the text to company.exchange, so the stock exchange, and the font weight will here be a light. And by the way, I'm just noticing that this should be semi-bold. It's just a visual thing. Doesn't change anything in the functionality, of course. And one last thing here is the color. That should also be our color on background. So now we successfully implemented the top row. The next thing that's missing is, it's actually just this text here with the symbol of the company. So that goes into this column. So below this row, we're going to have a spacer. Set the height to ATP, so just ATP of space, and the text will be like open close parentheses, and in here we will put the company.symbol. Here I like to have an italic style and a modifier of, actually not a modifier, we just want to set the color to material theme on background again. So nothing special here, if you know Compose at least. If you don't know Compose, then this is probably not the right course anyways, because this is already quite complex. And anyways, let's get to the screen composable. So now we have each item. Next up, we can create the screen. So in Company Listings, create the Company Listings screen. Make it a composable company listings screen. And this will now actually take something called a navigator, which is of type destinations navigator that comes from the Compose destinations library. And how that works, I will actually explain when we implement the navigation stuff, which we don't do here yet. We will do that when we also have the other screen. Yeah, it comes from the destinations library from Rafael Costa, actually. Little shout out here. Maybe you're seeing this. It's a great library. However, the library will take care of actually passing this navigator here, so we don't need to take care of that on our own. And the second parameter is our view model. So our company listings view model, and we get that from Hild. Since we inject our dependencies using Degre Hild, we can easily set that equal to Hild view model to get a reference to the view model in our screen. And with this destinations library, what we need to do for every single screen is we need to annotate it with add destination. Oops, destination. Just like that. And since that's our start destination, we want to set start to true. So that's super easy how we can now manage navigation in Jetpack Compose. A lot easier than the default way with all these routes and stuff like that. We don't need that anymore. We just annotate our screens with destination, and the library will generate all the boilerplate code for us. It will take care of the parameters to pass them in a type-safe way and all that stuff. So what do we need here in the screen? We of course want to have our swipe refresh layout, which needs a swipe refresh state. So val swipe refresh state is equal to remember swipe refresh state. And here we need to set is refreshing to something. And that is equal to view model state is refreshing. So when that actually changes, then this will automatically update our swipe refresh layout so that the little loading indicator will show up. And then let's just get a reference to the state here from the view model, which contains all the relevant UI information. And now in the end, what we will have here is we will have a column, and the column will contain the search text field, and it will contain a lazy column to actually show these items. So we have a column. Modifier will be equal to modifier.fillMaxSize. And in here, we want to create our search text field. That will be an outline text field in my case. The value and onValue change. Those are functions we need to implement and values we need to pass. The value is obviously coming from our state, the search query. An on value change? Well, whenever something changes here in the outline text field, we want to send an on search query change event to the view model with the new query. So view model on event, company listings event dot on search query change. Now let's do it like this and pass our new query here. We can do that in one line. Just like that. So that's how I always do it, to send these events from the screen to the view model, which just keeps it very crisp and clear. I think if you just have one class that contains all events that you are actually able to send from the UI to the view model. Then the modifier is equal to modifier dot fill max, actually padding first, 16 dp of padding, import dp, and fill max width. Just like that. We need 2 more parameters. On the one hand, we want to pass a placeholder, so that's what this search text is in the end. Oops. So text composable, and we say search, and max lines will be 1. I think we can also set single line to true. So then we have our outline text field. We probably want to have a little spacer beneath. No, we don't. We actually now directly want to have our swipe refresh layout. So that will be swipe refresh. The state is something we need to pass, and on refresh. So what happens if we drag to refresh? The state will be our swipe refresh state. And when we drag down, then we again want to send an event to the view model. So view model on event refresh. I can do it like this. And now what goes in here inside of this swipe refresh block is the content. So in the end, our lazy column, and when we scroll completely to the top in our lazy column and keep scrolling, then we will actually have the refresh functionality. So lazy column, set the modifier to modifier fill max size. And here we're going to have an items block with the list of T, and the list will be our company listings list. And let's actually not do it like this. Let's instead say items date companies dot size, and instead get an index here, because if that I is actually less than state companies dot size, we want to have a divider, and this divider will have a modifier, just a little bit of horizontal padding, 16 dp. I just want to prevent that the last item has a divider at the bottom. That's why we use this index here to check if we're currently not at the last item, then we show a divider. Above that, we want to have our company item, and we pass the company, which we can get here. That's equal to state companies at the index of I. The company will be this, and the modifier will be modifier dot fill max width. We want to say clickable, because we want to be able to click on these company items. And here we just leave it to do item, because we can't perform the actual navigation yet because we don't have the other screen. So here we say navigate to detail screen. And then after that, we can add some padding of 16 dp. And that's our screen. So that's the company listing screen. We can't test this yet, as I said, because we still need to set up dagger hilt and dependency injection, but that's rather quickly, something quickly. So let's actually do this next. So let's get to the last thing we need to do to at least try our app, to try the first screen with loading our listings from the API and caching them. and that is dependency injection. We need to set up Dagger Hilt here to be able to inject dependencies. If you're new to dependency injection and if you don't know what that actually is, in the end, it all comes down to giving an object its instance variables. That's really everything. So the most simple way of dependency injection is constructor injection. That just means, for example, what we do here in the view model, we just pass the instance variables, so the repository here in this case, to the view model. So we just pass it from the outside. That's dependency injection. So we don't create the instance of the repository inside of the view model itself. No, we pass it from the outside, which gives us a lot more flexibility because we can have different view models with different repositories, which makes testing easier because then we can have some kind of specific testing fake repositories. It just comes with so many benefits. And I would always advise you to use dependency injection instead of creating the objects here in the class itself. Let's start by creating an application class for that. That's what we always need to do with Dagger Hilt. I will do that here in the root package, new Kotlin class of file, and that will be called, let's call it stock application. And it's a very, very simple class. It will just inherit from application, and we simply annotate it with Hilt Android app to just tell Hilt that's our application class. That's where Hilt will actually get the application context from. So if we need to provide some dependencies that need an application context, then Dagger Hilt will actually know where to get it from. Let's next go to our manifest. And here we need to kind of declare this application class with this name attribute. So Android name, and we say stock application. And when we're already here, let's also not forget to add internet permission for retrofit, just like that. And then we can already leave the manifest. We can also leave this application file. And now the next step with Dagger Hilt is that we need to create modules. Modules are kind of containers or classes in which we define, in which we tell Dagger Hilt which dependencies we have and how it can actually create these. So for example, one dependency here would be retrofit. And to be able to inject retrofit, in our case, in our repository, here, this interface, by the way, these can all be private. In order to do that, retrofit, of course, Dagger Hilt, of course, needs to know how it can create these objects. And when I say injecting here, all I really mean is passing them to another object. That's why it's called dependency injection. So let's just go to our root package, create a new package, one that I forgot when we set up our package structure, and that is DI for dependency injection. And inside of that DI package, we will create our modules. So let's start with the app module, which almost every app will have. It will contain all the dependencies that will live as long as the application does. So that those are basically singletons. We need to annotate this with a module to tell Dagger Hilt that's a module, and also install in singleton component to make sure that these dependencies actually live as long as the application does. And let's actually just start to have a so-called provides function and a singleton. So we just say, hey, the result that we turn up this function will be a singleton, and this function will provide something. So it will provide a dependency. And well, now for every single dependency we would like to inject somewhere, we need such a function here. And let's actually start with retrofit. So with our interface, with our stock API. We call it provide stock API. And that will, of course, return a stock API. And now we just tell Dagger Hilt, hey, this is how you can create such an instance of a stock API. Nothing special. If you're a little bit familiar with retrofit, we can just create that with retrofit.builder. And then we have a simple builder pattern here, where we need to specify the base URL, which we have specified in the interface itself. We want to add a converter factory, which is the Moshi converter factory. So just that it automatically parses JSON to Kotlin data classes. And then we could call build and create passing, or we could also just import this create function, and then we're good to go. If you would like to change the client, so the underlying OKHTTP client, you could also do that here by passing a client, but there is no real reason to do that here. The next step is to also provide our room database, because that's what we also need in our repository. Let's do that next. So down here, another provides function, singleton, and we call it provide stock database. And that will return a stock database. So now how do we create this stock database? Well, we can simply return room database builder, and we need the context here. So how do we now get the context, the application context inside of this provides function? Well, we simply pass it as parameter, and Daggerhilt will provide that behind the scenes for us. So Daggerhilt will, by the way, just generate tons of boilerplate code behind the scenes that we don't see, that we don't need to see, just to make sure that it is able to inject these dependencies. And we'll also do a lot of passing of parameters in the background, like if we pass an application instance here, for example, it knows where to get that from because we annotated our application class with Hilt Android app, and we can now use that here to pass it as the context. I have more detailed videos, by the way, about dependency injection, so of course I can't dive too deep into this here, but I use it in pretty much any project video here on YouTube. The class is stock database, double colon class Java, and the name, let's call it StockDB. StockDB, I think you need to call it .db. Yeah, whatever. And we call that build. And there we go. Now we successfully provided our stock database. Do we need more dependencies? Well, yes, but not here. So right now we have our stock API. So Daggerhilt knows how to create it. And we have our stock database where it knows how to create it. However, if you take a look in the repository, it now knows how to create these two dependencies. It also knows how to create this CompanyListingsParser. We take a look here, because we annotated the constructor with @inject. If we do that, then we don't need to specify a provides function, because if Daggerhilt knows how to create such an object, if we directly inject everything in the constructor, then there is no need to specify a provides function, because it already knows how to create this object. Assuming all the dependencies the constructor needs are, that Daggerhilt basically knows where it gets that from. Since this constructor is empty, it can just create that object right away. So we don't need to provide this. However, the little thing here is that in where is it, our repository here? The repository does not depend on this CompanyListingsParser, it depends on a CSV parser, so the interface. And Daggerhilt is not smart enough to actually pass the CompanyListingsParser for this interface, because, well, doesn't mean it's not smart enough, it just, there could be multiple different types of this interface, and from where should it know which one to pass? So that's why we actually also need to kind of specify that. Since we actually want to inject an interface here or an abstract class, we want to do that in a different module right here, which I will call, let's call it repository module. And that will be a plain class, actually an abstract class. Will also just be a normal module, just like the other one, installed in singleton component, with the only difference that we will declare abstract functions here. And we don't annotate these with provides, instead with binds. So you can always annotate functions with binds if they are abstract functions, and this way it just eliminates a little bit of boilerplate code that is generated from Daggerhilt. And you can always use this if you actually provide an abstraction of something. So let me just write this down here and then I will explain it. Let's call it bind CompanyListingsParser. This will take a parameter, which is the CompanyListingsParser, and it will return a CSV parser of type CompanyListing. So here we say, okay, we want Daggerhilt to be able to inject an object of this type, so of CSV parser of type CompanyListing, and for that it should use this implementation. And then it will know how to inject this in the stock repository. So right here. It's a little bit more complex here what I do. And especially if you're very new to dependency injection, don't feel bad if you're confused, if you're totally confused. This is difficult stuff here. If you've never dealt with that. If that's too confusing, then feel free to just jump to next checkpoint or so and watch my Dagger Hill course where I go into this in a bit more detail. But I'll just go on here with singleton notation. And we also need to do the same for our repository, because in the view model, we inject a stock repository, which is an interface, but we actually want to pass the implementation here or provide that with Dagger Hill. So we can just do that here. Binds singleton abstract function bind stock repository. And here, instead of the listings parser, we of course pass the repository implementation and return the abstraction. Cool. Let's head back to our main activity. Because one more thing we actually need to do is we need to set up navigation before we can do anything here. First of all, we want to annotate this with Android entry point. What this is for is that also comes from Dagger Hill and allows us to inject stuff into Android components, such as activities. Since we will inject a review model here in the compose code, that's why we need this. Other than that, what we need to do is, so since we use Raphael's navigation destination compose destinations library, I forgot the name, we actually need to generate some code. Well, the library actually needs to generate some code for us. If we remember, we actually annotated this screen with destination, and that will tell the library which code to generate. So I think we are actually ready to do that. Let's go to build and rebuild the project. And then after that, we hopefully have some important classes that we need here and that we put in our surface in our main activity, so that we can actually, by default navigate to the company listings screen. Okay, my rebuild is finished. I hope yours is as well. So what we want to do is, inside the surface, we want to say destination is nav host, and here we need to specify a nav graph where we can just say nav graphs, that's a generated file, .root. Boom. That's our navigation setup. It's amazing. I love this library. So we don't need to specify any composable blocks anymore, any parameters, any routes. No, the library handles all that stuff for us in a type-safe manner. So really cool. And I would say we can try this out. So let me open my phone here and we launch this. For sure something will go wrong. That's the other app. So let's wait until it actually launches. There we go. Okay, it opens, but it seems like nothing is really loading. So we do have our swipe refresh layer. Okay, then it actually does something. So it just doesn't make the request initially, but that already looks quite cool. We need to change the background, or you can change the background if you like. But it loads all the entries. It looks almost like my other app, except for the background. Yeah, that's because I actually just allowed Doug theme only on my app. We can easily do this here as well, but let's see why this is actually not loading initially. We probably just need to go to our view model and just call this get company listings function here in the init block. So we just say get company listings for an empty query, so we get all items, and fetch from remote. Doesn't matter here, because if the cache is empty, so for the very first time, we definitely want to load this. That's the behavior we specified in the repository. And if we already have something in the cache, then the repository will load it from the cache instead and not reload it from the API. So let's just quickly fix the theming stuff. I will just copy over my theme here because I don't think I need to type this by hand. It is not a lot, just in the UI package. Theme. Here we want to get rid of the light color palette because I like to have dark theme only here. We replace this stuff with this stuff. And we need to create these colors, dark blue and text white. Let me also quickly copy these over in our colors file. So here in theme color, we replace all of this with these two colors. So that's our dark blue and our text white. It's just not total white, it's just a little bit darker, which I really like to have that on darker backgrounds, a little bit more readable. We go. Our colors don't need to be specified like that. We can just hard code them here using our dark color palette. Dark theme doesn't need to be a parameter here. I'll just leave it. And then I'm not sure if that already fixes everything, but I think it should. Let me relaunch this and take a look here. And yeah, there we go. That's how I want it to look like. So yeah, that's it for the first screen. And of course, let's try the cache, by the way, and the search. So if we search for Tesla, for example, there we go, Tesla appears. We erase this, then everything else appears again. If we switch to airplane mode, then my connection will actually break. Okay, that was a dumb idea, but believe me, the cache is working because the search is only a local one. So that's cool, that works. And the next part of this course will actually deal with what will it deal? With the detailed screen, of course, and making the cool graph, fetching the JSON data from the API. So enjoy. Oh, and of course, another checkpoint is reached. So you will also find this state of the application in GitHub. So we will start with the data part again for the company info screen. Let's actually take a look at the API here. This is the request that we will actually make when we want to request company info. You can see we get the symbol, we get the asset type, we get so much data. We actually just want the symbol, the name, the description, the country, and the industry. That's what I showed in my app. Feel free to show more. And what do we need for this? Of course, we just need to provide the symbol and our API key. So the symbol of the company, so the API knows with which company it should respond. And then we will show this in the app. And then the other thing that we will do is this one here. This is the intraday info. So just the information about the stock prices in a single day. I decided to do that here for this app. And that is for IBM here, for example. You can see it's a CSV file again, a table. We will parse this timestamp, and then we're interested in this close value, which we will then use for the chart. And the timestamp will be used to parse the time, so we can also have the x-axis on this chart. Let's jump back to Android Studio. And the first thing we want to do is we want to go to remote, and we want to have a DTO object, because a DTO object, as I said, a data transfer object, is used to kind of present the Kotlin representation of a JSON file, of a JSON response. Let's go here, create a new Kotlin class of file, and I'll call this CompanyInfoDTO. Just like that. Make it a data class, and in here we'll just specify the field that we have, which is on the one hand the name of the company, which is a string. And since the API has a little bit different names, they have like, yeah, always capital letters here, you can see, and we don't like to call our variables here with capital letters in Kotlin. That's why we need to add an annotation just to specify, hey, the API actually responds with a different name in the JSON response, and that is field::JSON. That's how we do that with Marshy, and then we specify, okay, it's actually spelled like that. And it seems like we need to use the named parameter, yep. And then we can simply duplicate this, I think 5 times. We do this for the description. We do this for the name, of course, and this should actually be symbol. This is name, that fits. Then we want to have the country. And we want to have the industry. Just like that. And then we will also just create a domain model for this, so we don't have marshy stuff in the domain layer. So we open this package, and here we create a data class. We can actually just copy this and remove the marshy stuff. So inside model, we paste this. We rename this to CompanyInfo. Also this file, control, actually shift F6, that's how we rename this stuff. Just CompanyInfo. And we remove this stuff. Just like that. Cool. And we'll do the same for the intraday info. So one more time, that's actually a smaller class. In DTO, we call that intraday info DTO data class. And well, what do we need here? We have a timestamp, which is actually a string. And we do have the close value, which is double. So the timestamp, as you saw, is just a string. It's a date string, and we will take this date string and parse it to an actual date instance that is more helpful to us here than just a string. That's what we will do in the mapper. Let's also have an intraday info in our domain models. So intraday info data class, and here we will also have the, let's call it actually date, and that will be a local date time. So in Kotlin, a local date time object is just, it's kind of a date time API, you can say, that helps us to very easily deal with dates and times. So when we have both a date and a time, then we use local date time. If you only have a date and want to calculate like plus 1 day, plus 2 days, plus a month or so, then you can see there is a local date as well. If you only have a time, there is local time, but we have both, so we say local date time. And we also have the close value, which actually stays a double. So let's actually start with this intraday info stuff, because the mapper for that is a bit more complex. Not complex, but compared to the other mappers, it's more complex. So in mapper, let's create a new file called intraday info mapper. And here we will create that mapper to take an intraday info DTO object and map it to a simple intraday info object from our domain layer. Intraday info. Just like that. And first of all, since we want to parse the date string, we want to define the pattern for that. And that is a string. So we simply say that is in this format, capital M for month. We have days, hours, minutes, and seconds. So that's just to specify, hey, that is the format of the dates and times. So if you take a look at this pattern, and if you take a look here, then it's exactly the same pattern. So we have year, month, day, hours, minutes, seconds. And taking that, we can easily parse it by using a formatter. And that is a date time formatter of pattern, because we want to build this from a pattern. The pattern is what we specified there, and the local is local get default. Then we want to get the local date time object from that formatter. And for that, we use local date time dot parse actually. And this will be our timestamp. So that comes from the DTO object. So the string, the actual date string. And we want to provide a formatter. We want to format that with, and that is our formatter here. Then we can return an intraday info object, where we can pass the local date time object as a date, and the close value stays the same. That's it for that. So you can see that's really useful now that we have this mapper, because the DTO object is not the same as the domain level object. It's much easier for us in code to deal with the domain level object, because we use our Kotlin datetime API, or the Java one, which we can now use to very easily calculate with these dates and times, which we can't do with a simple string. So that is another reason why we have these mappers, because DTO or entity and domain models very often differ, and we want a very convenient way in our domain models to deal with these in our code. We need one more mapper here, which is rather simple, and that is in our company mapper. I'll just put it in this file, and that is to convert a CompanyInfo DTO to a CompanyInfo model. So function CompanyInfo DTO to CompanyInfo, return a CompanyInfo, this one, and here we can just return a new CompanyInfo object. The symbol will be equal to symbol, and here we actually need to make a null tag. Actually made these fields non-null, but we need to change that because when your quota is actually used, which is pretty quickly the case if you just have a free API key, I think if you make more than 5 requests per minute, then the API won't respond with a JSON response, like not with the CompanyInfo response, but instead with like another JSON response that says, hey, your quota is used, and then it won't find these fields. So if we make these non-nullable and we try to access these later, it will crash. If we make these nullable, then we tell it, hey, these fields are not always included in every response. That's why I do this here. Same for description, and then we just pass empty strings. The name, what else, country, and industry. Just like that. Then we want to go to CompanyInfo DTO and just make sure that all these fields are nullable. Just like that. Then in here, everything will look fine. Okay, next step is to go to our repository and, or actually not to the repository. Let's go to the API first and add our 2 more functions that we need to access the API. On the one hand, to get company info, so the JSON response, and on the other hand, which is a separate request, to get the intraday info, which we need to populate our chart. So first of all, for the intraday info, that's a GET request again. We want to get a CSV file, and I'll just paste this string here. Feel free to write it off and pause the video here. So we basically just say, okay, we want the intraday function here for the API. The interval is 60 minutes, so we get the close values for every 1 hour basically, and we want it as a CSV file because that also is available for JSON, but it's easier to parse that if it's a CSV file for us here in Android. Let's call that get intraday info, and here we need to again just pass the symbol we want. So the symbol of the company we want to get the information for, symbol string, and we want to also attach our API key, which we also can just get here from our file. And what will that return? Since it's again just a CSV file, we just return response body to get the byte stream. That's it for this request. The next one is to get the JSON data for a company info. So another GET request. And let me quickly write that off. It's a query and the function is just overview. That's a little bit easier. URL here. We say suspend function, get company info. And what do we need here? We of course also need the symbol of the company you want to get the information for. And we need our API key. Just like that. And this will now not return a response body because we directly get that as JSON, and then Moshi will parse it to a data class. So we need to return the data class we want to parse it to, and that is in this case a CompanyInfo DTO. And then we will take this CompanyInfo DTO, Moshi parse it to, and transform it to a CompanyInfo domain model, which we would rather like to deal with in our code. Cool. Now that we have these 2 functions, we can implement them in the repository. In StockRepository in domain first, just specify how these functions will look like here. So in the end, it's pretty much the same, just without API key. So get intraday info. Here we want to pass the symbol. And we will return a resource. What kind of resource is that actually? It's just a list of intraday info objects. So just a list of values basically that we show in the chart. And then we have another suspend function here. Oops. Suspend function get company info. Also passing the symbol, and that will give us a resource of actually not just company info here. Cool. Now we can implement these functions in stock repository implementation. The very bottom, I would say, Control I, Control A, Enter. So for intraday info, we want to return a try and catch block because we again do a network call where things can go wrong. We want to catch IO exceptions on the one hand, and on the other hand, we want to catch HTTP exceptions. And again, I won't do any fancy error handling here. I'll just make sure to print the exceptions. And then we will return a resource, that error in these cases, with an error message that says couldn't load intraday info. And we can actually copy this stuff, paste it here as well. And in the try block, we just use our API to get the intraday info, or let's say val result or val response is API get intraday info. The symbol is what we passed here. And then we want to actually parse this to a list of intraday info. So this response again is just a response body now. And we know that that's a CSV file, but we need a way to parse it to a list. So we again need a class to map it actually, to take this, read the byte stream and map it to a list of intraday infos. So we go to our CSV package and we actually just copy the CompanyListingsParser and paste it in the same package called intraday_info_parser this time. Because that's a very similar one. We again just want to have a CSV reader. Just this time, this is not a CSV parser of company listings. Instead, it's of type intraday info, because that's the type of the object we return here. Just like that. We still want to read everything. We still want to drop the first line with the titles of the columns. And this stuff here now differs. So if we take a look, we're actually interested in the timestamp and the close value. So that is index 0, the timestamp, and close is index 1, 2, 3, 4. So we're interested in index 0 and 4. So we can say timestamp is this, close value is 4. That's not needed. And then we return an intraday info with exactly these values. Since we need the date here as local datetime, I don't want to create the intraday info directly. Instead, I just want to create a DTO here and map it, because we just have the mapper for that. There was no reason here to do that directly or have another parsing here from date from the timestamp to date. So the timestamp is timestamp, and the close is close to a double, I would say. Like that. And then we can say, okay, we return DTO to intraday info. And here we actually need to return null if that field doesn't exist. Like that, and then we're good to go. I think that is, no, that's not everything. When I Look over here, we still want to do something here that differs. That is that we want to, of course, make sure that we, of course, order this by the hour. So we have an ascending order of the hours, that we start with the lowest hour and end with the highest one, of course. And we want to also filter these, because I'm not sure if that's the case here with IBM, but if we take a look in this table, yeah, you can see there's some entries that have a different date, like a totally different date. And we actually just want those values from the last day, because I don't want to show it from the current day, because then it could be that there's just a single value or no values at all. I just want to take the values from the last day. We know it was a whole day, and that's why I want to filter this here. So we say filter, and we want to filter these infos by it.date day of month being equal to local date time dot now dot minus days. I'll explain this. Dot day of month. So what does this mean? We just keep all these entries, so only these entries where the date of the intraday info is equal to yesterday, basically. So we take the current day, which is this, we subtract the day to get yesterday, and then we refer to the day of month. And if that matches, then we know that we want to keep this, because it's an intraday info of yesterday. And then we want to say sorted by it date hour. And you can see how handy that now is that we have this data object, because if we would have that as a string, there would be no way for us to make these easy checks here. And that's why that's one reason at least why we have domain models, because these are much easier to deal with. And then we want to head back over to stock repository implementation, go to the constructor and simply duplicate the last line, call that intraday info parser. That's a CSV parser of type intraday info. And then we can use this now here to parse the byte stream from the response. So let's actually save this in a results variable, and then we return that as a resource. That's success with results. And there we go. We don't have any more errors. That's pretty good. Let's head over to the next function, this one. Return try catch again. I'll just copy the catch blocks here. So our exceptions couldn't load CompanyInfo this time. And here in the try block, we say API, or actually let's say, well, response is, or rather result this time, because we directly get a DTO object, is equal to API, get company info for the symbol. And then we say resource, success, result. That's a lot easier. So here we don't need any mapper. I mean, no CSV mapper. We of course need to map this result now to a company info object, but then we're good to go. Nice. That works. Now we actually have the data layer for our company info stuff as well. Let's also deal with the dependency injection right now. So we have one more parser here that we need to provide. And I think that's it. Did we do more? I don't think so. Let's go to repository module and just copy this parser here, paste it, and just have the same for the intraday info parser. Say that's our intraday info parser. This one as well. And we return a CSV parser of intraday info. That looks pretty good. And with that, you also reach checkpoint number 6, I think it is. So yeah, that's another checkpoint, and we will now go on with the view model for the company info screen. and just, yeah, the basic state handling and stuff like that. Then we will deal with the chart, which will be a little bit more complex, but also probably something new for most of you to deal with canvases and stuff like that. Drawing on the screen, and then, yeah, just the actual screen is left. So enjoy. So the view model will be in our presentation CompanyInfo package, a new Kotlin class of file called CompanyInfoViewModel. Select class here, that will be a view model. And again, the same stuff here with Hill view model, nothing new. Add inject constructor. Import inject. What do we need? On the one hand, we need the so-called saved state handle, which is a way to get access to navigation arguments in the view model directly without passing them from the UI to the view model before. Very handy because we need the symbol when we navigate from the listing screen to the detail screen. Then we of course need to pass the symbol of the company we clicked on, so we can make the API request using that symbol to get information about that specific company. And we need access to our repository again, so we inject that as well. Before we go on here, I want to create the state class for this view model, which represents the whole screen state for our CompanyInfo screen. So in CompanyInfo package, we go and create a new Kotlin class called CompanyInfoState. Data class. And what do we need here? On the one hand, we need a list of, which I will call stock infos, and that is a list of our intraday infos. Setting it to an empty list by default. So that will be the list that we will use to populate our chart later on. Then what else do we need? We need the company itself, which is a CompanyInfo object. Nullable, because initially, yeah, there needs to be an initial value, and when we get that from the API, then there's a little bit of delay till we have that object. Then we need is loading boolean, which is, let's set it to false initially, and an error message. Just an optional string, which is also null by default, but if there is an error, then we just pass something here. We just show a red text on our screen. Then let's go back here and create our var state by mutable state here, just like in the other view model. Import that, both getter and setter, and then we will create an empty CompanyInfo state object. And now, what do we want to do in this view model? Well, we of course want to get the company info. So we need to access our repository to access that information, to make the API calls and all that stuff. So we immediately want to do that once we navigate to the screen. So in the init block, we will launch a coroutine in viewModel scope. And here we are ready to call suspend functions. First of all, we want to get the symbol that we need to make the API calls using the saved state handle. .get, we want to get a string, since the symbol is a string, and the parameter is called symbol. And actually, if that's null, we return at launch. So we don't want to go on here. That's never the case anyways. And before we start, we want to say that the state is now loading. Before we make the API call, we want to start loading, want to start showing the progress bar, and then we can get our results. We need to make 2 API calls here, and we can do it like this. So val, on the one hand, we want to get the company info, which actually company info result it is, because we get that as a resource. And that is repository get company info passing the symbol. And then we also have the intraday info result is repository get intraday info passing the symbol. And that's now a very common coroutine mistake here that many beginners do actually. What's the problem with doing it like this? This will of course work. However, we do 2 network calls in the same coroutine, one after another. So it will first do this network call, once that's finished, it will do this network call. And there's actually no reason why we can't do these two network calls simultaneously. So then we will actually finish in approximately twice as short of amount of time. You know what I mean. We will be quicker. So how can we fix that? We can fix that with async. So we can launch a new coroutine in here, an independent one with async. And no, Siri, that's now the third time here you're interrupting me. This one is async as well. So as soon as we launch this coroutine here with async, it will start that network call, but it will do that independently here of the outer coroutine. So then we can have our when expressions. On the one hand, we want to say CompanyInfo result. Let's actually do when val result is CompanyInfo result dot await. So now with await, we actually get the result from that coroutine, from this async block here. So whatever this returned, as soon as it's ready, without actually blocking this coroutine. And if that is resource success, we want to do this. If it is resource error, we do this. And else we don't want to do anything. We don't have any loading values here coming from this function. If that's successful, then we actually just want to map our state to state copy, and the company is equal to result.data, because that's what is the actual company info object here. If we have an error, or actually we also want to say is loading is false now, and we also want to say the error message is nothing. And here, if we get an error, we say state copy is loading is also false, and the error message this time is, what is it? We want to say result.message. And let's also set the company object back to null, so that only the error really displays. Then we can take this, copy it, and do the same for intraday info. So intraday info here, intraday info result. This time it's not the company, instead it's the, how's it called, intraday, what is it, stock info? Yeah, stock infos. And this is a nullable list. Yeah, if it's null, we just say empty list. That looks good. So that's it for the function to get our company info stuff, including the intraday results. So now the only thing that's really missing is the UI for that screen. And yeah, only is good because it's quite a lot of work to make this chart. There will be a little bit of math involved, but let's actually do that step by step and everything will be clear. So the stock chart will be a simple composable that we put in our company info package here. So new Kotlin file called stock chart, and select file, make it a composable stock chart. And I will say right away, there will be a lot of numbers here, and we will have a lot of math and a lot of things that might not be immediately clear. And that's pretty normal when dealing with canvases and stuff, because especially, when you deal with coordinates and canvases, then it's very common that you just try around a lot until things look good. That's what I also did. So that's why for you, some numbers and some calculations might seem a little bit weird, but that's just a result of me playing around till it looked good. So don't worry if not everything is too clear here. It's just canvas stuff. That's how it really is. It's just a bunch of math to draw stuff on a screen. And also this chart is everything but perfect. You will find that sometimes there is like a number missing on the like the last one. For some companies it isn't. I just didn't want to spend too much time for this chart. I think it looks good. Like we have a nice curve, and yeah, but if you really want to optimize that and spend time for that, then do it. I don't plan on publishing this app. I just wanted to have a cool chart there where especially the chart looks cool, and I didn't spend too much time on the actual axis. So without further ado, let's jump right into it. What kind of information do we need to draw this stock chart? Of course, we need the infos, which is a list of intraday info. Empty list. We need a modifier, compose one. And we need the graph color. So we can surely choose our very own color for the graph. This one from compose is equal to, I'll set it to color green by default. First of all, I want to have some spacing, which I'll set to 100 pixels. So all these values will be pixel values here when dealing with canvases, or you use DP values and convert them to pixel. So the spacing will be basically everything, like, let's start with that. That will be our canvas. So that is an area we can draw on. And obviously we need to draw this shape here given all these different values. Like these are our close values and these are our time values. And these texts here on the left, on the axis, and on the bottom, these are also drawn on the canvas. So those are not text composables because we need to make some calculations here because we want to draw, in this case, 5 texts here on the y-axis. And for that, we need to make some calculations and specify at which position at the screen we want to draw these texts. And now I established that spacing, which is actually just the distance from where this graph starts to the very, to x being equal to 0. So this distance here, and also from the bottom here. So then we also want to have a transparent graph color. And that is equal to, remember, and I will explain what that is for. Graph color dot copy. We set the alpha to 0.5f. So you can see we in the end have a color gradient here from the graph color towards a transparent color. But if you would use full transparency here, then it wouldn't look good. It would stop somewhere here. And I found that if we use like the same graph color with like 50% alpha value, then it looks pretty good and stops right before the end. And that's exactly what we do. We just copy the color and set the alpha to 0.5f. Then the next thing that we need is we need to calculate the upper and the lower value of the close values in our infos list. So the upper value would be this value here, and the lower value would simply be this value here. We need to calculate these so that we know how to, like which values lie in between, so that we can kind of interpolate between these, because these close values are, of course, not always in the same range. Like for Tesla, it could be, it is here 1093, but for a different company, it could be like 100, it could be 50, it could be 500, something else. So that's why we need to calculate the upper one, the lower one, and then interpolate the 3 values in between. So we say upper value is equal to remember, and we use remember here, by the way, so that we make sure that we don't recalculate these values every time on a recomposition. That's the same for copying the color here. So here for the upper value, how do we get that? We want to say infos max of or null. We're going to calculate the maximum of the close values. So we just go through this list, and this will return the maximum of the close value. And if there is no maximum, it will return null. So if it's an empty list in the end, we're going to say +1. Then we want to say round to int. And if that's null, we want to pass 0 instead. Looks super complex. That's one of the things I mean here with just trying around. I found that it works just the way I wanted it. When I added 1 on top of the upper value and then rounded it, because integer roundings are always floor roundings, so it's always rounded to the lower number. And that's why I actually wanted to round it to the upper number. That's why I just added 1 here. And if the list is empty, we'll just use 0. Now we do the same for the lower value. So lower value is remember. And by the way, here we also actually want to pass infos as the key. So that means that the remember value is actually recalculated when infos changes. And here as well. And here we want to say infos min, off, or null this time. So this time we want the minimum, of course, of it close. And we want to say to integer, and if that's null, we say 0. Because for the lower value, we actually want to take the lower value. Like we want it to round to the floor. So that's why we don't need this plus here or any minus or so. Then the next thing and the next concept when it comes to dealing with a canvas is paint. So when we want to draw something on a canvas, at least with the older canvas of Android, like with the XML canvas, which we have to use at least for the text here, because the Compose canvas can't draw text directly, but we can refer to the native canvas, like the older canvas, and draw text with these. And these used so-called paint objects to determine how things look on the screen, look on the canvas. So when we want to draw text on the screen, we need to specify, okay, what is actually the font size? What is the color of the text? Is it centered? Is it left aligned or whatever? All that stuff is specified in the paint object. And that is what I want to do here. We want to have a text paint object by remember. And here we actually, first of all, want to specify, actually create the paint object. Make sure to use Android graphics paint here, not the Compose one. And we say that apply to modify this. I want to say color, for example, is color.white. And here we actually need to use the Android graphics color. Exactly that. So we need to specify the package name for that. Not an issue. We want to say text align is equal to center, so that also the coordinate at which we place the text is the center of the text and not the top left corner as it would be usually. And we want to specify the text size. And here I would actually like to set this to 12 SP, which this canvas sadly doesn't take, and there's also no function to pixels or so. So we need to specify this in pixels, but we want it to be the same size as our other text that we specify for the text composables, which are 12 SP. So we need a way to actually convert these 12 SP to pixel values. And for that, we can use the density object. Density is local density.current. We pass it here, so whenever the density changes, we recalculate this paint object. And then we can say density.run, and we say 12 SP, and now 2 pixels, because this 2 pixels function is contained in this density object, kind of. How that works. So yeah, we have our text paint, which we will need to draw text on our screen. Now we can finally create our canvas here, which is simply a composable. So we just create an area to draw anything, any kind of shapes, any kind of images on the screen. We have our full freedom, and we can just specify coordinates where we do that. We can specify how we rotate all that stuff. And if you actually want to learn more about Canvas and learn cool animations, learn a lot more detailed stuff than I can go into here, then I actually do have a very detailed course about that, which I will link in the description. Just check it out. I do have some cool GIFs on the course page, where you can quickly see what you will actually be learning and what you will be capable of doing after the course. Okay, let's actually pass a modifier here, the one we passed to the function. And then we will open this block of code. First of all, what do we want to draw? I actually want to start drawing the texts. So on the one hand, we want to draw these 5 texts, and on the other hand, we want to draw these here. So how will we do this? First of all, I want to specify a variable called space per hour. And this variable can be calculated by using size.width, that refers to the width of our canvas, minus our spacing. And then we divide this simply by infos.size. This actually refers to the x-axis here. So even though I showed you the y-axis here, we now start drawing these hour values basically. And the space per hour is, just the value in pixels, how much space we have in between each hour in pixels. Because that will be needed to draw these hours. So what I will do is I will say 0 until infos.size minus 1, step 2. Looks very complex. We say that for each and give this the name of I. So what happens here is we just loop through our infos in the end, and we only take every 2 hours. So that's why we have step 2. So if you take a look here, we have like 5, 7, 9, 11. So it's just every second hour basically, because otherwise this would look way too crowded if there are a lot of hours on a given day. That's why I have the step 2 there. And now for every single I, we will draw a single text. So the info we can get from our infos list at the index of I. We can get the hour from info date.hour. And now with these informations, we can actually draw this on our screen. And as I said, we can't do this with this compose canvas directly. So you can see if we type draw, there are tons of functions we can like draw circles, arcs, images, lines, ovals, paths, points, rect, round rects, all that stuff. But there is nothing for text. Luckily, that's still very easy. We can just say draw context, canvas, native canvas, apply. And here we get access to this native canvas. And with that, we can actually also draw text. That's what we want to do. That takes a bunch of parameters. First of all, the text you want to draw. That's of course the hour. So hour.toString. Now we need to specify the x coordinate at which we want to draw this text. That will be spacing plus I times space per hour. So let's think about why that's the case. So spacing, as I said, is this amount of pixels. Then we take I times space per hour. So I starts at 0. So it would be 0 times space per hour. And remember, this would be space per hour. This would be space per hour here. Basically all the spaces in between. If we take 0 times this space, we will end up with 0. So we start at just spacing for the x value. For the next number, for the next hour, I will then be 2 because we have the step 2. So it would be spacing plus 2 times space per hour. So we will actually exactly land here at the 7. So 1 space per hour would actually be half of that. And then 2 space per hours would be this. Hope that makes sense. For the y value, that's a little bit easier because that's the same for all fields, for all hours. That's just size.height, and I'll subtract 5 here. It's a random number, I know. You can give this some better names, but I just found this to be good. So the text actually aren't cut off by the canvas. Size.height just refers to the height of the canvas. So here would be y being equal to 0. And here is y being equal to the height of the canvas. And then we subtract 5 pixels. So we actually here in terms of y values. And then we need to pass our paint. So we specify how the text actually looks on the screen. And we just pass our text paint. And there we go. We now successfully specified how we want to draw our x-axis hours. Let's do the same for our close values. So the price in the end for the stock. Outside of this loop, we will have another loop. And here we first want to calculate the actual price step first. So with that, I mean, in this case, it would be 4. So that we actually just show a number every 4 units or every 5. It depends a little bit how it rounds. but that it approximately fits. So what we will actually do is we will have another for loop, not right here. We will have it outside of that one, and we'll have a price step before that where which you can just get from taking the upper value, subtracting the lower value, and dividing it by 5 because we have 5 numbers that we want to show. And then we can say 1 to 5 for each. Again, because we have 5 numbers. For every single I, we want to draw something into our native canvas. So draw context canvas, native canvas, apply, because we want to draw text, same as before. And well, starting with the text we want to draw, that's the actual number we need to now calculate. And that will be round. We will take the lower value, we add the price step times I on top of that, and say toString. So let's try to understand what this means. So the lower value right now, if we take a look here, would be 1075. Starting with I being equal to 1, we would then, what do we do here? So we say price step times I. So price step is actually 1 here. I think it should actually start at 0. This is quite spontaneous change here, but then it makes more sense to me right now. So we start at the lower value. So it would be 1075. Then for the next round of I is actually 1. So we say lower value plus price step, which would be 4 or 5, depending on how it's rounded here, times 1. So we add 1 step on top of that, and we are at 1080, and so on and so forth. I hope that makes sense. So then what's the X value here? I will actually hardcode this to 30 pixels. Not the best way to do it, to be honest, but yeah, you could have tons of more variables that make this a little bit more readable here, but I don't want to spend like hours and hours into this stock chart when the focus is actually on putting everything together in a well-designed and structured app. For the Y value, well, that's of course dependent now on I as well. We can say size.height. We subtract the spacing, not space per hour, just spacing, which is again this value here. And we subtract I times size.height, and we divide this whole thing by 5. That is in the end how we get the Y value of the close prices. And the paint will still be our text paint. That's it for the other axis values for the Y-axis. Then we can now get to the actual graph and draw that. So a little bit info before how we will do this. It looks very complex. It actually isn't so complex. The thing we will use to draw this is called a path. So obviously this is a path, and while it looks like it's super hard to draw this and with all these curves and stuff like that, it's actually not. You can think of it just like we draw things in a coordinate system, and we have all these values from the CSV table. So all we need to do is we need to draw them on this coordinate system. So we just transfer them to the canvas coordinate system, and then the path can be used to just smoothen these lines. So we don't have we have all these corners and stuff like that. No, we can actually use paths to use so-called Béziers, which are used to kind of make these curves, and that will be pretty cool and not too difficult to draw. But again, in my Canvas course, I go much deeper into this, how these Béziers work, how the math behind that is like, all that stuff, which I won't go into here. So we're going to have something called a stroke path, and that is equal to a new path object from Compose UI Graphics. We say apply, and now we get access to this path, and we can say something like move to, we can say line to. So it's just like a pen, you can say. So it starts at 0, 0 by default. We can now say move to this location, draw a line to this location, draw a line to this location. And yeah, that's basically how we deal with paths. It's not as easy as drawing lines here, because then we would have corners and we want round, smooth lines here basically. But let's actually start with a move to command. Or actually, let's not start with a move to command. We first of all want to calculate some values that we need to, we kind of need to transform the close values from the CSV table into our canvas coordinates. So first of all, I want to just have a little reference for the height, just so we don't need to type this all the time, because we need this quite often. And then we will actually have a for loop for I in infos.size. Actually not .size, .indices instead. So we just loop through our infos list. So through all the intraday infos, which contain the close values here, this one. Then for each of these, we actually have a point, a coordinate in our coordinate system. So we have the current info, let's just call it info, I would say, and that is infos at the index of I. And then we also want a reference to the next info. So the next one basically the one that comes next, and that is infos get or null I plus 1, so just the next one. If that's null, we instead refer to infos that last. Because obviously if I is the last index, then there is no next info, and then we just kind of draw a line from the last point to the last point, which won't be visible, but just to avoid that it crashes here because of an index out of bounds error. So now my idea behind this, how we transform these coordinates from the actual values into our coordinates of Canvas, is that we calculate them as percentage values, as ratios you can think of. So if this point here would be 0%, then we would transform this value, which would be 1080. We would transform this to, I don't know, maybe 20% approximately, because this distance is 20% of this whole distance. And if we have these as percentage values, we can very easily calculate with that, because we can then simply take these values and multiply them with our canvas pixels. And then we get the final pixels where we want to draw the lines. Very complex, I know, but just the general concept behind that, so you're not totally left behind in what I'm doing here. So first of all, we actually want to have the left ratio, which is the this percentage value of this info point, so of the left point, and then we'll do the same for the next info. So we have two values, and then we can draw a line in between these two. Left ratio is info.close minus lower value divided by upper value, parentheses, upper value minus lower value. That is just a formula we can use to map one interval of values to another interval of values. So the first interval would be, like in this case, 1075 to 1093, and we map it to values between 0 and 1. So to just percentage values. And that's the normal formula for that. You can just Google for it. That's where it comes from. We do the same for the right ratio. So again, we choose the actual value first. So next info close, we subtract the lower value, and then we divide it by upper value minus lower value. Just like that. If I is now equal to 0, so if we are at the very first coordinate, we actually want to move our pen, you can say, to the first spot. So to wherever we want to draw the first point, the first line. So what we're gonna do is, if I is equal to 0, we say move to which coordinate? Well, the x value is actually spacing plus I times space per hour. And the y value is height minus, or a spacing value, minus left ratio times height, and to float. So what the heck does that mean? The y value, I think this is not too complicated here, but the y value is kind of, so we take our height, subtract the spacing. So the height would be this whole thing. We subtract the spacing, and then we subtract left ratio times height. So let's say left ratio is 20% here. And we would then multiply this with the height and subtract that from this difference where we are currently at. And then we would actually end up at this point. It's really difficult actually to show these things in a course with all these calculations, but I hope it somewhat gets clear what I'm doing here. Let's just move on. What comes next? We will now calculate the actual x and y coordinates of the left one and of the right one. Well, of the left one, we actually already have it here. So this is in the end, the coordinate of the left point. So if we connect 2 points here, let's say this one and this one, then we just calculate the coordinates of this point. And we now also want to do this for this point to draw a line between these two. So what we can do is we can actually say before that, val x1 is spacing plus I times space per hour. And we have y1, which is just this stuff. And then we can say move to x1, y1. We also want to have x2 and y2, obviously, because that's for the other one. This would be spacing plus I plus 1 times space per hour. And we can copy this, paste it here for y2. Here we need to change this to right ratio. So now we have those two coordinates and we can draw a line between these two. If we are at the first coordinate, we move to this. And then afterwards, we can start drawing the line. And for that, we use something called a quadratic Bézier. These are the mathematic calculations which make it a smooth path. So without any corners or so, if we actually make use of that correctly, which we will do. So you'll see we now have two kind of values here for x1, y1, x2, y2. And for that we will pass x1, y1, and for the x2 and y2 values, those are actually not the x2 and y2 values we have here. Instead, when we deal with these Béziers, we have something called a control point. The control point decides about how smooth and how in which direction the curve goes. It's something I really don't want to go into here. I go into that in my Canvas course, but it determines how the curve is rounded, basically, and from which direction and stuff like that. And if we just have two coordinates and we want a smooth curve between these two coordinates, then there is a formula for that, which you can also just get on the internet. And that is that we just add the x coordinate and the next x coordinate together and divide it by 2. So that would mean we have x1 plus x2. We divide it by 2f. That would be the coordinate for the x value of the control point. And the same for y, just like this. And that will just make a smooth line. Yeah. Feel free to Google for what these Béziers actually are, then you will understand it on a deeper level. This is not a math video here, so let's just go on. So what we now did is we now did the stroke path. So we drew this green path here on our canvas. What we didn't draw till now is actually this transparent gradient below this graph. And that's actually another path, which doesn't look like one, but a path can also just be a shape without a stroke. And we can give this shape a gradient. So we'll just draw the same path again, draw down, draw left, draw up, and then give it a gradient. That's how this will work. And luckily we can just copy this path with a little trick by saying val fill path is equal to, here we actually need to use the Android graphics path, not the compose one, since with the compose one we can't copy paths. So we say Android graphics path. And here in the constructor, we can provide another path which we want to copy, which is the stroke path. Since that's a composed path, won't work, but we can convert that to an Android path. And then we want to say as composed path, so we convert it back to a composed path. As I said, that's just to copy this, and then we can say apply and do some changes on that path. So at this point, we have the exact same path that we have for the actual, like this line basically here, the green one. And now we actually want to draw it down, left, up to make it a full shape, so we can give it a gradient. So we actually want to draw a line to, so this is now just a straight line, to the last x coordinate, which we don't have here as a variable, and just size.height minus spacing. So we now have the pen right here, and we want to draw a line to the last x coordinate, so x should stay the same as it is here, and we want to draw it to size.height, which would be this, minus our spacing, so we actually end up here, and then we draw left and up. How do we get this last x? Well, we actually need to fetch it here in this block before, so var last x is 0, 0f, I would say. And here we can then just assign something to that. Last x is equal to x1 plus x2 divided by 2f. And we can pass it here. Then the next line goes to spacing, size.height minus spacing, so y doesn't change. And then we can say close. So close just means we connect the current coordinate of the path with the starting point. Now the difficult part is actually done. Super difficult to explain actually, this is quite a challenge. But now the easy part comes, we just need to draw these two paths, which is very easy to do. So first of all, we say draw path. We want to start with the fill path because the fill path should be behind the stroke path, so it doesn't hide any parts of the stroke. The path we want to draw is the fill path. Then we can give it a brush, which we can use to give it a gradient. So brush dot, what is it, vertical gradient. And here we can define color stops. So from which color we want to transition to which. Well, that is the list of. Want to start with our transparent graph color, so it draws from the bottom to the top, and then to the graph color. Actually, I'm seeing I handled that a little bit differently. I passed color transparent here. So I actually, there was something that wasn't fully correct what I said before, that this would be 50% of our graph color. No. Here on top, that is actually the graph color with 50% alpha, and this is fully transparent. Yeah, so then it makes sense. We transition from the transparent one, from top to transparent, so it goes from the top to the bottom. Yeah, now it's correct. And what else do we want to pass here? We just want to pass something for the end y value, so where we want the gradient to stop, and that is just our size, height minus spacing again. So we don't want it to stop like below our numbers, just, yeah, exactly where our graph ends. And then we can actually draw the other path for the stroke. The path is the stroke path. Then the color is our graph color here. And the style, to just draw the stroke, we don't want to fill it. So we say style is stroke. This one here, we can give it a width of 3dp.2 pixels. And we're going to say cap is round. So the stroke cap is just that the ends of the path are basically rounded. Cool, we did it, guys. That was quite a challenge to make this stock chart. So let's actually make use of that. and build our screen, which is a lot easier than this. You also, of course, reach your checkpoint here with the stock chart. So yeah, you will again find a branch with the code here right now in the GitHub down below. Okay, so let's just create the screen and then we are done with this app. In CompanyInfo, new Kotlin class or file, and call it CompanyInfo screen. Select the file, make it a composable, CompanyInfo screen. And we annotate this with destination again because, oops, that was the wrong one, I think. This one from the compose destinations library, because that's another screen we want to be able to navigate to. We need a view model here for sure, which is a CompanyInfoViewModel equal to HildViewModel. And we actually also want to pass the symbol here, which we don't need on this screen, but we need to pass it so the library, the destinations library, actually puts it as a navigation argument. It will automatically do that for the normal primitive types here or for parsellables. So we have access to that in the view model, but we don't need it here on the screen. So let's get a reference to the state from the view model, our CompanyInfo state. And then we want to check if the state error is equal to null. So if there is no error, we want to show the normal screen. And that is just our column. So in the end, if we take a look here, it's just a column with a bunch of text and then our stock chart. Nothing too special. The column has a modifier. Fill max size. Oops. Let's give it a background of our dark blue. We say padding is 16 dp. And that's it. I think, yep. Let's go in here and we say state.company ? let. So we make a null check here for the company. The company will be non-null as soon as it's loaded from the API. So then we will automatically show it. Let's give it a name of company here. Like this. And then we can use the information of the company to actually draw these text on our screen. So we have text here. Text is equal to company.name here. First of all, we want to give it a font weight of bold. We want to set the font size to something bigger, like 18 SP. What else do we want to change? We want to say overflow is ellipsis. So for very long texts and for very long names, we actually cut these off with 3 periods. And we make sure to simply fill the max width. I think we can actually copy these here quite often, these texts. Let's have a spacer in between with a height of 80p. And then just copy this, actually together with the spacer, to be honest. Next up is the symbol of the company. Like that. That's not bold, that is instead just italic. So we set the font style to italic. The font size is 14 SP and we don't have an ellipsis. Then I'd like to have a divider between these texts here. So we can say divider. We can say, okay, the divider actually has a modifier of modifier.fillMaxWidth. That's already enough, I would say. We could also give it a little bit of padding, like horizontally, 16 dp, but I don't think we need that because we already have padding in the outer column. We can copy the spacer down below. What comes now? I think the industry. So let's just copy this text here again. Here we actually have a text industry and pass the company industry. No font style. The font size is 14sp, that's fine. And I will also again make the overflow in ellipses. Copy this spacer and industry again. Now we have it for the country. Oops. Company.country. Rest is fine. Then I want to have another divider, so we can just copy this exactly as it is. Paste it below. And then we have the description finally for the company. So here, just company description, and the font size is 12, so a little bit smaller. We can remove the ellipses. And now comes the exciting part, our stock chart. So if the state stock infos is not empty, so if we have some entries in the intraday info list, we want to show the stock chart. First of all, we want to show the text market summary and actually have a little bit of space before. Let's set it to 16dp. Copy this, paste it below, have another 16dp of space, and then we can actually say we have our stock chart. We want to pass the infos, which is state stock infos. Want to pass the graph color. Actually, no, green is fine. We want to pass the modifier instead. Modifier, fill max width. We need to set a height here actually because each canvas needs to have a fixed area to draw on, so we can't you can't really work well with dynamics sizes here. So we say 250dp and we say align center horizontally and import that. Cool. That's it for the main screen already. Nothing too special here, to be honest, just column and texts and spacers and one stock chart. One more thing is actually the loading indicator and the potential error message. So at the very bottom, we will check if, actually let's have a box instead. And then we will check the, if we're loading or not inside of the box. The box will have a modifier of fill max size and a content alignment of center. So here we will, center, can I say alignment center? Okay, I think I need to do this. Yeah. Then in here, we can simply check if state is loading. When it shows circular progress indicator, which is just centered on the screen in that case. If not, so else if the error is not null. So if we have an error, we want to show the error message. So text, and the text is state error, and the color is material theme colors error. Yeah, so the error would just be centered on the screen. Super simple here. Just that you get a general idea of how I would do error handling. At least how I would take the errors from the API and propagate them to the UI. In a real app, I would do more fine-grained error handling. But I think that's it. We now need to worry about the navigation from the one screen to the other, which is super simple. So in company listing screen, we have our navigator. Want to use that here where we have our to-do statement in the clickable block. I want to say navigator.navigate, and we navigate to, I think we need to actually rebuild the project to generate some classes. Let's go to build and rebuild. Wait until that's finished. And for some reason, my nav graphs is not found. Not sure why. Okay, it seems like I can re-import this here. Just import that and remove this. Not sure why, but doesn't matter. So in company listing screen, we can now say we want to navigate to CompanyInfo screen destination. That's a class that was generated. And here we can pass the symbol just as a normal parameter, which is company.symbol. Awesome. That's navigation. And I think that's it. Like, it's very likely something is not going to work, but I think we're ready to try this out. Let's launch this. And at the very end of the video, I actually have a homework for you, so make sure to watch these last few minutes till the end. But let's first of all launch this here on my emulator. There we go. Let's search for our good old Tesla again. And when we click on that, we get to this page, and okay, seems like the stock chart is not displaying. That's a bit weird. Okay, so at least this is loading. But I will probably need to look into this, and then I will get back to you with the solution. Okay, guys, I found the issue. It's so dumb. Everything is actually working. I'm just recording that on a Monday, and it filters out everything except for yesterday, and yesterday was Sunday. On Sunday, nothing is happening at the stock market, so there is just no data. So yeah, feel free to take it as a homework to come up with a better solution here, to just like take the last day where it can find some data or so. So if I take like -4 days here, then it would work. It does find some data, so I'll just leave that here to show you that it works. But just in case that some of you try this out on a Monday or on a Sunday, then it's pretty good to know that. Also, I found another little issue. I changed this local date time to local date. Not sure if that's actually an issue, but yeah, I actually had that different in my prepared project. And one more thing, in the stock chart, here I changed this up to 0 to 4. This was actually 0 to 5, and then we would actually have one step too much. Those were actually the few minor issues we had here. Let's launch this and take a look here. So if we now search for Tesla, hopefully that now works. Open this, and yeah, there we go. Okay, it is actually overlapping with the market summary a little bit. So it seems like we just need some more spacing. But other than that, it looks awesome, I think, with this chart. Looks exactly the way we want. We have five stock prices there on the left, on the x-axis, on the y-axis, and also some nice hours on the y-axis. So let's just add some more spacing here for actually, yeah, here below the market summary. Let's make it 32 dp, I would say. I think that's fine. And yeah, guys, that's it. My goal really was to show you an app that how you can basically put all the best practices together, all the architectural guidelines, having some cool extra features that I don't have yet on my YouTube channel, like the stock chart, something that just goes beyond a note app, beyond a to-do app or so, something that's exciting, that involves caching, that involves something new with CSV parsing. I really hope you liked this and learned a lot here, so definitely let me know below how you like this video, if you learned something new. And as a little thank you for those of you who actually watched this till the end, I actually have a discount for you for my more advanced courses. So if you say, okay, Philip, this was an amazing course and I want to take this to the next level, then I do have more advanced courses that go even more in detail than this one here. For example, my multi-module course, which covers like how you use clean architecture in a multi-module project. Right now, we only use a single module here, which is this app module. But there is a way to use more of these and to have a stricter separation of these concepts, a stricter separation of like data, domain, and presentation layer. And that's really difficult to do, actually. And in this course, I will really go in depth with that, in that topic, how you can structure an application so that it actually scales to an industry level. So for that, I will give you a 10% discount. You know, I rarely give discounts for my courses, but here, for those who actually watch this till the end, are quite serious with Android development. So you will get 10% with the discount code stock-market-app, not only for the multi-module course, but also for the Canvas one, because this was quite related to that, and to the ultimate course bundle. So if you say, Philip, give me all your courses, then you also get 10% on that. So down below, you will find the links to my courses. Would be really cool if you just check them out, even if you don't plan on buying one. Just check them out. What would you get there? And yeah, that's a pretty good way to pretty good way for me as well to maintain this channel. So if you want to support me in my work as well, then getting one of my courses is an excellent way to do that while still getting a very good value out of that. Now let's get back to the homework that I promised to you, and that is, on the one hand, the spontaneous one is, as I said, here in intraday info parser here, that you come up with some kind of solution, that it always at least shows some data, and yeah, even on Mondays. But the actual homework I wanted to give you is that you implement caching for CompanyInfo. So right now we only have a cache for the listings, but it would be cool to also cache the stock charts and to cache the information, because yeah, the API key is kind of limited, and if you cache it, then you can save a little bit on your quota. So take it as a homework. You really only learn if you practice on your own. No course on this planet can teach you Android development if you are not willing to put in the work and also practice on your own. So let me know down below how you like this, and yeah, I really hope this helped some of you and helped you to learn how to build a really solid app. Thanks so much and enjoy your day. See you back in the next video. Bye bye.